Okay, so the recording is in process. So let's go ahead and get started here. Let me just get this out of my own way. Okay. So what we're going to look at this morning is environmental concerns and infrastructure concerns. So why essentially we care about chloride and chloride impairment. Then we're going to talk about winter maintenance in terms of the time that happens. So we'll talk about pre-season preparation. And I'm just going to go ahead and mute all the lines here because we've got a little bit of background. And you can unmute yourselves. Okay. So we're going to talk about pre-season preparation. So this is your site inspection, your expectations. Calibration is probably the most important pre-season thing. Then we're going to talk about pre-treatment, so activities that you're going to be looking at before the storm. Then we're going to look at during the storm activities, so your plowing, salting, sanding. Then record keeping and salt accounting, and finally a focused review. So one thing I like to be very clear on, you guys are the experts, right? Every storm is a unique situation. Roadways and parking lots are unique. Your citizens are unique. There's really too many variables for me to tell you exactly how to do something. So this is going to be kind of general concepts. You're probably going to think of situations where you disagree with what I'm saying, and you're probably right. But you guys all know that this is kind of high-level theory. But keep in mind, this is just kind of the tools to have in the toolbox so that you can apply it to your unique situation. You know, winter's the most challenging season, as you guys all know. If we were talking about summer road maintenance, we would all be in complete agreement on how to maintain a road, how to build a new road, all of that sort of stuff. Pretty formulaic. We would all agree. Winter maintenance, there's so many variables. You know, between the equipment and the weather and the type of precipitation and the pavement temperature, the roadway itself, the condition of the pavement, you know, if you have high quality pavement or low quality pavement. So it's really a windy path and requires a lot of nuance and knowledge on the part of the folks that do it. One of the other challenges we find when we look at winter maintenance is we have on the left here the amount of money that you want to spend, which is no dollars. You have at some middle level, usually somewhere around 15 to 20 storms a year, somewhere in that neighborhood. So that's kind of what your average cost is going to be to undergo winter maintenance. But then you have all the way on the right, you're required to be prepared for any number of storms, right? So this is a really challenging topic and a really challenging task. It doesn't matter if you get 30 plus blizzards, you still have to go out there and take care of it. So it's really tough, you know, planning for materials, planning for manpower and equipment. Nearly impossible to get it 100% right. So what we're going to be talking about now is safe and effective use of salt and using it efficiently. And what I like to stress here is safety is priority number one. This was actually on I-93 in New Hampshire, around the Salem, New Hampshire area, southern New Hampshire. This is not what we want. This is absolutely not use less salt and the roads are going to be less safe. We want to use just the right amount of material to get the job done. And people will frequently say, you know, well, how much material could I save? It's only you would know that, really. It depends on how much you're using now. You might already have this really dialed in, and this is just a refresher. And you're already employing these techniques, so you don't really have much more savings to get. Or you might not be calibrating, and you might not be doing some of these things, in which case you might be able to save quite a bit of material. But throughout, safety is priority one. So now we're going to look at kind of the cost of salt. So this was a study done out of Montana State University, at the Transportation Institute. And they were looking at the cost of salt, the total cost of salt. So buying it, transporting it to you, putting it down on the roadways, and then the damage that is done subsequent by the chlorides on the roadway. They came up with about $470 per ton was the total cost of salt. So they looked at that for the state of Michigan. They use about 500,000 tons a year. They're saying the indirect cost of salt, they took that 470 number and cut it down to 200 to be conservative. So they projected out what is the total cost of salt. You're looking at $4.16 billion over 10 years. So if we can talk about saving 5%, that's big money. So when we start talking about the environmental impacts of chloride, a lot of it's infrastructure based, and my background is actually in civil engineering, so I gravitate towards infrastructure when thinking about chloride. So you've got a couple things that you're looking at here. You've got concrete spalling off the deck there. You've got some corrosion of the stringers. You've got that pier cap with some pretty serious corrosion problems. When we talk about chloride damage of concrete, it's everything down to your sidewalks, and you'll see this kind of white chalky residue well into the summer when it rains. You'll see the sidewalks with the pop-outs like this. So why does this happen? Why do we care about chloride in infrastructure? Well, it's not really about the concrete. It's about the steel inside of the concrete. So all you need to have rust is water, steel, and oxygen. Chloride is just a helper. Chloride makes it go faster. So what happens is you have your 2.5 inches of cover over your rebar, but eventually that chloride starts migrating down through and eventually gets to your rebar. What happens then? It starts to corrode. So you've got this salt, you've got this water, you've got your steel, you've got oxygen. So what's actually happening is you're turning that steel into rust. And we all know that rust is a lot bigger than steel, right? There's a huge volume expansion there, and it's that volume expansion that actually blows the concrete off. You might think, well, this is similar to frost heaves, right? You get a lens of water, the ice is larger than water, you get that expansion. That's about 50,000 PSI outward force, which is why it's able to lift up the whole roadway. If we're looking at corrosion, corrosion's 75,000 PSI of outward force. So once you get that corrosion starting on the rebar, it's really tough to stop. So that's really the issue with your concrete. It's more the steel that's the issue. This is why sometimes you'll see, and I don't know that they have any in Connecticut. We have a couple of them in New Hampshire. They actually made some bridge deck with carbon fiber reinforcing bars that have been up for about 20 years. They're not even paved over. No corrosion at all. There's nothing to corrode. Why that doesn't happen more, I'm not really sure. The steel industry probably has something to do with that. But that's kind of your issue with corrosion in concrete. Of course, it affects smaller things, right? It rusts everything out. Pretty big problems actually with these automatic doors. You'll actually see the salt in the water migrate all the way up into the overhead mechanicals, cause quite a bit of damage there. This was sent to me by a friend out in Michigan. These benches are right next to each other. They're actually under an overhead balcony. You can kind of see the pillars there. They were installed at the same time. The only difference between them is the one on the left is covered by the balcony and the one on the right is not. It drips right down, and that's a concrete balcony that was sanded. So you can see the deterioration, how rapidly it happens when you get that sort of exposure. We also look at vegetation death, and now I'm not a biologist, so I'm going to keep this fairly high level, but you've all seen the grass that looks like this where you plow and you get the salt on the grass. So we look at why this is happening. So it really goes down into the root tip. So this is the part of the root that actually sucks up the water. And this is a little bit in the weeds, but kind of go with it here. So what we're looking at imagine those gray boxes are kind of the wall of the root. So inside the root is supposed to be saltier than outside the root, right? There's salt inside the plants. And it's actually that difference of salt and no salt that allows that absorption of water into the root through a process called osmosis. So what are we doing? We're putting salt down in the outside world. So now you have salty outside, salty inside. You lose that difference in concentration. And that's actually what's happening to the plant. It's dehydrating because it's not able to uptake water because it's salt and salt. There's no difference, so it doesn't absorb. So that general process is what you're looking at for any sort of plant death, aside from mangroves that actually like the salt water. So any freshwater plants, this is what you're looking at and why you get the vegetation death. So aquatic species also impacts fish. So saltwater fish are built this way. They're meant to gulp a lot of water and excrete a lot of water out of their skin. So if you look at saltwater fish, they're supposed to be less. You're going to have to use your imagination with these gray blocks again. Now it's a kind of a fish skin. So on the right-hand side, inside the fish is meant to be less salty than outside the fish on the left, so they excrete water out of their skin. Freshwater fish are built backwards. They are meant to be saltier inside than outside. So what are we doing? Inside the fish is supposed to be saltier. We're putting down salt. So you lose that balance, and again, it's dehydration. Are you going to kill your fish like this? Probably not. Other smaller things, salamanders, things of that nature, newts, they're kind of the first ones to be affected. Other wildlife impacts. There have been, this is a little out of date, more like 15 reports of bird kill in the US and Canada. And bird kill is like 50 plus birds just dead. They get into salt, about 2.8 salt crystals will actually kill a sparrow. Again, dehydration. From a transportation point of view, think about what we're doing with creating salt licks on the side of all of our roads, right? You're drawing your moose, your deer out of the woods to the side of the road where they might get struck by a car. Going a little bit further, you also have soil degradation. So in healthy soil, the nice fluffy soil, you're meant to have bacteria. They cycle the nutrients. What actually happens when you put down salt is it kills that bacteria, and then you get the soil degradation. That's a desert, obviously. That's not around here, but you kind of get the idea. You kill that bacteria, destabilize the soil. You've all seen the ground like this next to walkways that are treated with salt during the winter. The soil is as hard as concrete, which leads to subsequent problems of erosion, right? You completely destabilize the entire network, basically, which leads to further problems. So chloride contamination. I know we have 47 contaminated watersheds in New Hampshire. A little backstory on where this training came from. In the expansion of I-93 south and north, which is amazingly still not done, in getting that permit from the EPA, they found that the watersheds all on that highway were contaminated with chloride, and the EPA refused to give them their environmental permit for the fourth lane that they wanted to put in. So the DOT started engaging in salt reduction techniques, and we developed this training to deploy to municipalities and more specifically to private contractors. So we spent quite a bit of time gathering best practices from all across the country and put together kind of a comprehensive salt management platform to use less salt and get their permit from the EPA to pave the fourth lane of I-93. Which I can report back, it's about 10 years later that we've done this. I think all of the watersheds except maybe one are in compliance, and the one that's not in compliance is really, really, really small. It only has an off-ramp on it. So they're thinking about just doing no salt on that off-ramp. But I can report that these techniques work. You know, we've had people save anywhere from 20% down to 5 or 10% of their material. But has anybody been in or has chloride contaminated watershed in your town? I'd be surprised if there wasn't anybody. If you're anywhere near a highway, you probably are in a chloride contaminated watershed. And once you kind of get into the EPA's monitoring process, really hard to get out. They have not unwound the watersheds that they've been monitoring in New Hampshire yet, even though they're in compliance. I don't think they actually have a mechanism to do that yet, but we should be looking at that soon. So as I mentioned, I have the handicap of having an engineering background. So my first thought when the environmental people came and started talking to us about this was, well, we made a mess, let's clean it up. That's what we do, right? So you start to look into how do you clean up salt? Really difficult, as it turns out. The best cleanup options are distilling, which is essentially boiling, vacuum distilling, which is boiling again, but you put a vacuum on the water to lower the boiling temperature, so a little bit less energy required, and reverse osmosis, which is a very expensive filter. So if you're looking at any meaningful cleanup option, it doesn't really exist. This is actually a shot of a desalination plant in San Diego. $300 million capital cost, 30 to 40% more to operate this than a traditional drinking water treatment plant. This does millions of gallons a day. Connecticut River's 12 billion gallons per day. So if you're talking about cleaning up just the water in the environment, it's not really going to happen. So we know where this is coming from, right? It's coming from us. We're putting down thousands of tons of salt in the course of winter maintenance. So the only thing that we can talk about is being a little bit more efficient with how we put down this material. So when we look at chloride impacts, I do this at the end of each of the sections. So we're going to kind of take it up to a high level here and talk about the big picture items from each section. So chloride impact review. So salt has hidden infrastructure costs, right? It basically rusts things, whether the steel is inside of concrete or not. It also negatively impacts life. So plants, the dehydration, because you lose that salt differential. Fish and aquatic life, again, dehydration because you lose that differential. And finally, human health. And we didn't touch on this, but you will find drinking water wells that get contaminated with chloride. In New Hampshire, the DOT spends in the order of $250,000 a year, I believe, last time I heard, putting in new wells that get chloride contaminated because they're along the highway. And if you're someone that has high blood pressure, hypertension, and you have salt in your drinking water, that's not a good scenario if you're trying to monitor your salt. So like I said, we know where the chloride contamination comes from. It's from winter maintenance. It's from municipal folks. It's from private folks. And there's no viable way to clean it up. And as I mentioned, kind of the biggest problem that we had in New Hampshire is, the DOT adopted these technologies, the municipalities adopted these technologies. And the private sector folks said, the first time I put down 1 less pound of salt in a storm and somebody falls, I'm going to lose my shirt. They're going to say you didn't put down enough salt. You weren't maintaining a safe, whatever they were maintaining. So in New Hampshire, there's actually legislation that gives you liability protection from slip and fall. You can find it at the New Hampshire Department of Environmental Services website. It's called Green Snow Pro. And it gives private sector folks liability protection from slip and falls, provided they take this course, are implementing the techniques that we're going to talk about. And it gives them slip and fall protection for themselves, for their company, and it extends down to the property lessee and the property owner, if those are different entities. So it's a pretty powerful piece of legislation. I think it's really common sense. So if you do happen to have a chloride problem and you've addressed it to the extent you can at the municipal level, there is a model in New Hampshire to kind of deal with the private sector folks. It's been pretty successful. We proposed the bill twice before it passed. On the third time where it actually did pass, we bumped into some major construction that was being held up, and all of a sudden it went through without a problem. So it is a neat model. I know they've looked at adopting it in Maine. and Vermont. I don't think either one have done it yet, so I think New Hampshire is the only one with that liability protection, but it's pretty good. Any questions or comments on chloride impacts? Okay. A little bit more and we'll be done with the environmental portion of the training, and we'll get on to the actual fun stuff. But since we're on the environmental side of the world, I do want to bring up sand. Sand is generally worse than chloride from an overall environmental point of view. A lot of people will think right off, well, if I need to limit my salt, I'll just go to sand, problem solved. Yes, salt problem solved, sand problem, you just made a new problem. Generally speaking, sand is worse for the environment, and it's typically not recommended for temperatures above 15. And we'll talk about why that is in detail. But essentially, above 15 degrees, you should be able to actually start melting and loosening that bond with your de-icers and actually be able to remove that material. When it does go below 15 degrees, now you're below the capability of most salt, unless it's treated, to be able to actually get any melt. So this is where you switch to your winter sand. And I see it around quite a bit now. The storm we just had was really cold, which is why we got so much snow. And you saw everyone switching over to the salt sand mix because it's too cold for the regular salt unless you're treating it with something or unless you have a calcium chloride. So the big thing with sand is everything you put down, you're supposed to clean up. And even after you do a great job cleaning it up, you're going to miss between 50 and 90%. Where does it go? You know where it goes. You go fish it out of there. It goes in your ditches, your culverts, your drains. It goes into rivers and causes sedimentation, which changes the geomorphology, which is no good. And it's actually regulated by the EPA in terms of water quality. I did some training out in northern Nevada, the Reno area by Lake Tahoe. And the problem they were having there was sand. So if you've ever been to Lake Tahoe, it's up in the mountains, and it's basically a big basin in the mountains. So all of the roads that go to Lake Tahoe go down. So and they get a tremendous amount of snow. So as they were maintaining all of these hills essentially during the winter, they were using sand, and the problem they were having was Lake Tahoe is really famous for being clear. You can see, 100 feet down in Lake Tahoe, and they were losing that clarity because of the sand that they were putting in during the winter. So they had me come over and train them on how not to use sand, how to use salt, and how to do it appropriately. But, depending on the situation, sand is just as bad, if not worse, for your environment than salt. So the idea and kind of the general theme of, what we're going to be talking about today is using the right amount of material to get the job done for the storm and the conditions that you're seeing. So that's what we're going to focus on. I will not tell you not to use salt, even though this is a course kind of focused on reducing your salt usage. There is the fact of life that salt is the cheapest, most readily available de-icer around, so that's obviously what you're going to use. We can enhance it by adding things to it, but I'm under no illusions that people are going to buy the chemicals that cost 100 times as much because they're a little bit more environmentally friendly. So this is very salt focused, trying to keep all the recommendations realistic to what you would actually do and not have kind of pie in the sky stuff that maybe looks good on paper, but you would never actually do out in the winter. Any comments on the environmental side of the world? Okay. So let's get a little bit into this. We'll stop at 10 o'clock and just take 5 or 10 so folks can get up and stretch and so forth. So let's talk about preseason. We've got all the environmental stuff out of the way. Let's talk about what we might be doing in October, maybe in September. So a bunch of different things that you might be looking at. site inspection. So actually getting out to the areas that you're going to maintain, whether they're parking lots, sidewalks, roadways, highways, whatever it might be, and kind of taking stock of everything that you have on that plow route in that parking lot, and make sure that you address any issues that you might be able to before the winter season. We'll also talk about things that you might find on your site that'll present a problem, like maybe porous pavement. Another good thing to do is to establish a snow and ice policy if you don't already have one. This is basically just a simple recording of plow routes and priorities, frequency of sidewalk treatments, mailbox policy, that sort of stuff. Just having a documented municipal policy is really helpful, and is actually kind of the backbone of your municipal liability protection, is having that policy to publicize what you're going to do and then sticking to that. Training and trade organizations, obviously you're at a training now. We'll talk a little bit about other trainings that are available in trade organizations. And then probably the most important thing, calibration. We're going to talk about calibration a little bit. If I were there, I would calibrate a truck with you, but unfortunately we'll just have to kind of talk through it. And we'll send out a couple good videos. There's 5 or 6 YouTube videos that are really good on calibration. They talk you through the whole thing. We might skip through one. I don't want to make you watch the whole video, but we might just take a look at it for concepts. So parking lot site inspection. I like to do this starting with aerial photos so that you have something to kind of jot down your notes on. But you're looking for a bunch of things. Where are the drainage structure? Which way does the water drain? Are you storing any materials or equipment on site? Where are they going to be? If you're going to have to store snow on site, where's that going to be? Is there anything unique going on, like porous pavement, that you're going to have to deal with? So if we just look at what we might be documenting here, this is a town hall in New Hampshire. The first thing that I like to look at, this picture was taken in the afternoon, and that parking lot on the right-hand side is actually the main parking lot, and the main entrance is in that giant shaded area. So I'm going to spend a fair amount of time telling you to use less salt, but it's all about context. That is the main entrance to the building, and you can see it's very, very shaded. So you're going to have to use more salt there because it does not get that solar exposure. So this is kind of the type of efficiencies that we look for. You've got no trees or anything around the rest of the parking lot, so you can probably get away with a little bit less there. But where you have that foot traffic in a very shaded area, you're just going to need more salt to get the job done. So an important data point is knowing the amount of square feet if you're working on a parking lot, and then just doing kind of a simple documentation. You know, this is where we're going to store our snow. This is a brick paver, a couple thousand square foot walkway here. This needs to be hand shoveled. This intersection goes down in both directions, and you can't see around the guy's equipment that parks it in the corner. So that needs a little bit of extra treatment. You got a raised catch basin over here that we don't want to smash into, and a fire hydrant over here that needs to be cleared. So kind of the idea is just getting a little bit of documentation about what's going on in the parking lot, what you need to be careful of. And a lot of this is getting the institutional knowledge out of people's heads and onto paper. So if you've maintained this parking lot for 10 years, of course, you know all of this stuff. But if you happen to be out sick and somebody else is getting to this for the first time, this type of documentation is helpful to make sure that they don't forget to shovel out that fire hydrant if they're supposed to. So a lot of this preseason stuff is kind of just getting things documented and getting the knowledge out of people's heads. Nobody on this call would ever do this, but I have seen this a few times. I didn't take this picture. I got it from a buddy. Of course, if you're storing snow and salt on the same site, number one, you're going to have your salt pile covered. So that's the first thing I would look at. Number two, you don't want to store snow upstream of salt such that when it runs, it goes right down through that. And I have seen this in real life. I've seen it twice, actually. So I just mention it so that you're a little bit cognizant of the way that the water drains. Other things that you might look at or find, particularly on parking lots, you don't see it on roadways very much up here, is porous pavement. And if you're not familiar with porous pavement, it's a trick to get a permit to put pavement where you're not supposed to have pavement. So you'll find a lot of times you'll need to put in a parking lot, a roadway, what have you. And you won't be able to get your stormwater permit because there's too much pervious surface, too much pavement that can't drain. So if you want to build it badly enough, you might switch over to porous pavement, which from a permitting perspective counts as grass. Doesn't count as pavement at all because the water drains down through it. It is cool stuff. When I first got involved in winter maintenance stuff and salt reduction, this was what everybody thought was going to be the answer. So, well, you know, you'll melt the ice and the snow and it will drain right down through it. It's going to be amazing. No, it's not amazing. So it's basically a gap graded concrete. You can have concrete or asphalt. They just skip gradations when they make the mix, so they create voids. And then they have a special way of compacting it so that they don't fill those in during compaction. And then there's many feet of sand and stone, again, a particular gradation below it so that the water drains all the way through. So it's great for getting your permit. You'll know it if you see it. It looks like this. It looks like a rice cake. It looks like terrible pavement, basically. What almost everybody forgets is this is supposed to be vacuumed 2 to 4 times to prevent clogging. I have never seen anybody vacuum their porous pavement, which is why it gets clogged. If you've ever been on I-93 in Georgia, or I-95, excuse me, in Georgia, they have a lot of porous pavement, which works really well because you don't get the spray back. But when we're looking at it from a winter maintenance point of view, the recommendation is actually that you're probably going to need to use more salt on the porous pavement. It's pretty highly dependent on sun exposure. If you have a very black asphalt porous pavement and it's getting a lot of sun exposure, you can have that magical effect of the ice melting, draining down through, there's no refreeze. Doesn't happen often. So generally you're going to need to use more salt, unfortunately, on this, and it's really because it drains off the brine, which is what accelerates the melting. So it handicaps it. So the big picture when you're dealing with porous pavement is you do not want to use any sand ever because that'll clog up. And they're, of course, going to blame you when it's undoubtedly clogged up for other reasons. Try to make sure it's being vacuumed. I've never seen anyone actually vacuum it, but it's recommended. And you're probably going to have to use more salt to actually get that same melting done. It is neat stuff, though. There's a couple videos on YouTube about porous pavement. You can see they're just dropping water on it, drains right down through. So it is neat stuff. You'll see it around from time to time. Sometimes as just kind of stormwater experiments, and other times because they want to get a permit. Anybody have porous pavement in their towns already? I'm sure some of you do. Okay. Let's go a little bit further here before we take a break. So another thing you can look at when you're thinking about preseason is inspecting your plow routes. So you're going to take note of any steep inclines, sharp curves, areas that are shaded by trees or buildings. We don't use snow fences very much around here, but if you did, you want to make sure that those are all in place. And I know a lot of you already have all of this documented. Always good to take a ride on your routes in the fall, though. See if there are any potholes or things that need to be addressed before the winter season. And make sure that everybody's familiar with any changes that might have taken place since the last winter season. Trees that need to be cut back, anything of that nature that you might be able to address before the winter. Also, time to think about equipment a little bit. So when we think about equipment, I like to bring up AVL, automatic vehicle location. And this used to be something that was, you know, drivers did not want this, right? Nobody wants Big Brother tracking what you're up to, where you're doing, but it's gotten kind of neat, and I do like to highlight it a little bit because Not many organizations actually have enough people to have a big brother just sitting in the office watching other people work. So some of these guys are changing the way the technology works. It's kind of a neat focus. So it can track your position. Obviously, it knows where the truck is. It can tell if your spreader is on. It can tell if your plow is up or down, reports to a central database. The part that gets kind of neat now is it's a lot more driver focused. So they're looking at actually reporting your location to other drivers in real time. So you can kind of see where the whole fleet is at. And this gets pretty useful in urban areas. So if we look at here, this was actually in Boston, Cambridge, Massachusetts. And what we're looking at here is actually an in-cab display. And this system, I think, runs on an Android tablet. And it actually leaves a snail trail of where all of the other vehicles have been. So you can kind of see there that green line and see truck 371, and you can see where he has been and where he is right now. So they did this as kind of a pilot project, and they were able to save about 30% of material because they could see where their overlaps were. You know, if you're the green truck driving down Washington there in the middle, you know the purple truck has been there within the last 60 minutes. So you might drop your plow, but you don't need to apply any salt because you know somebody has just recently been there. So I like to bring this stuff up because I think the focus has changed a little bit. You still have the same benefit of, you know, you can prove where you were when somebody says, oh, you didn't plow my street this morning. Yes, of course, you can go in the database and say, actually, we were there at 6:25 in the morning going by your actual house. It was this truck. It was this operator. So all that stuff is obviously still there, but they're kind of trying to layer in more situational awareness tools and more things that the drivers can actually use in real time, you know, layered on top of the traditional things that you would use an AVL for. These are also fairly cheap now. You know, you're looking at $500, $600 usually for one of these units. So they've come down in price quite a bit over the years, and they're getting to have some neat technology to keep an eye on. So I mentioned snow and ice policies. Really, these are just about expectation setting. And WestCOG does have some samples that we put together a few years ago. They're fairly basic. It's basically about setting the expectations for your citizens, protecting yourself and your citizens. So most states have what is known as municipal sovereign immunity, which means that it's acknowledged that you have a finite budget, you have a finite amount of equipment, and a finite amount of staff. And as long as you have a plan and you're following the plan to clear the roads and the sidewalks in the winter, you're generally immune from any sort of prosecution for slip and falls and things of that nature. But that plan is typically the backbone of, you know, this is something that was drafted by the town. It was reviewed at the select board meeting. It was adopted by the town at public meeting. You know, this is our policy. And as long as you're following that, that adds a good layer of protection. What do you see in these policies? Well, probably the most important thing would be a road priority. We're looking at here, this is actually Reno, Nevada has theirs up on a GIS map, which is kind of cool. So this is actually theirs. So we're looking at, I say orange, it's kind of more yellow on this screen. These are your multi-lane priority 1 roads. The blue roads are your single lane priority 1s. Red roads are your school bus routes, and then black are your priority 3, which are the roads you're going to get to last. So just your residential roads, cul-de-sacs. So just having this sort of priority system documented, publicized is really helpful. It's not going to stop the phone calls, of course. I don't think anybody has the secret trick for that. Other things to think about including in a snow and ice policy is if you have a property damage policy, mailbox policy typically, it's good to have that in there. And if you have any sort of intergovernmental agreement, so if you have mutual aid with neighboring towns, good to document that. If you have any arrangements with the DOT, good to get that documented as well. So it's basically, you know, just a central document I like to tell people these are always working documents. I've seen some folks get really hung up with drafting really huge winter maintenance policies that are completely comprehensive. Totally fine to have a version 1 that you adopt. You can always amend it if you want to. All you have to do is get the vote again and you're good to go. So it's nice to have a simple snow and ice policy. You don't need to document every last thing in the world. Other good preseason activities. You're taking a training right now and it'll be recorded, so you'll have that available to you. There are other trainings available that are really good. I don't know if anybody is a member of SIMA, the Snow and Ice Management Association. It's more of a private sector focused group. And a lot of it is honestly how you make money in the snowplow business, but they do have some really good technical trainings. They have a couple conferences that are really neat to look at. And of course you have the LTAP program at UConn, I think in Connecticut, right? The local road center. So I'm sure they put on a number of winter maintenance trainings. Those are always great to look at and get a refresher on. But probably I said the most important thing I hope you take away from this training, if you're not already doing it, is calibrating your equipment before you use it. And I always come back to, well, we're talking about using less salt, right? So we're talking about using too much material. So maybe we can agree on too much material. I think that's probably too much material. This was actually, I took this myself. This is, I'll drop the dime. This is the University of New Hampshire when I was working there. This was the sidewalk that I walked up to get to my office every day. That is a lot of salt. I mean, if we zoom in, it's like complete coverage of salt. One thing that you don't see any of in this picture, snow, ice. You don't see a lot of grass next to that walkway either, which small wonder there. This was actually a pre-treatment, which we'll talk about pre-treating with solids. You definitely can do it. You don't do it like this, that's for sure. This is not the operator's fault though, really. He was out there at 3 o'clock in the morning before a storm, and he was in one of these little holder sidewalk plows. They have like a little poly dump that's just at like a 45-degree angle, so gravity feeds down, little agitator at the bottom. So he was told to go pre-treat, go anti-ice before this storm. If I'm remembering right, I think it was going to be a pretty bad storm, and I got here before the storm actually happened. But all he did with his spreader is backed up and drove away. That's what came out the back. He wasn't necessarily doing anything wrong that morning. What he was doing wrong is not calibrating his equipment. And I like to show this picture because if you're not calibrating your equipment, you might be doing that and not realizing it. I've calibrated many trucks that they're dialed in really nicely, and others where it's staggering how much comes out the back. And you'll find a lot of times people, they have the right answer, or kind of the right answer. When you say, well, how much are you going to put down? You get numbers like 300 pounds per lane mile, 500 pounds per lane mile, which are the right numbers. You need to change it with pavement temperature, but those are the right numbers. We all agree on the numbers. But you can't just say 300 pounds per lane mile. You got to actually calibrate your equipment so that you can say, well, I'm in truck 105. I want 300 pounds per lane mile, which means I need to have the gate at 1.5 inches, and I'm going to use belt setting 2 and go about 15 or 20 miles an hour. And you can calibrate any piece of equipment, old equipment, new equipment, fancy equipment. If you have fancy equipment, your manufacturer will have a method of calibrating it. But you can calibrate absolutely anything with the methods that we're going to look at. So why don't we take a break here? We've gone just about an hour, and maybe come back at 9:05, and we'll start up the calibration discussion there. Just give everybody a couple of minutes to stretch. Okay, folks, let's get started back up here. I've got 10:05. So calibration, we're going to talk about calibration in a couple of different ways. The first one's going to be very basic and probably not a way that you would actually do it, but I do like to talk about it. it's very easy to understand. And if you haven't calibrated before, it just kind of gives you an idea of what we're looking to accomplish. So this is looking at kind of manually calibrating for a parking lot. So what you would do is actually mark out on the pavement 2 10-foot lanes. So this would be for your travel lanes, and then 2 5-foot out of bounds areas, which would be your parking spaces. And then you'd want to measure 50 feet. So the reason we have these particular dimensions, the 50 feet in particular, is because all of our parking lot application rates are in pounds per 1,000 square feet. So simply all we've done is created a 1,000 square foot test area, and we're just going to essentially drop salt on it, pick it up, and see what we did. So we're talking about parking lots. You generally, if the parking lot is in use, don't have to be too concerned with salting the parking spaces. The vehicles will take the salt there on their tires. So you generally just focus on the lanes. Parking lot's not in use, obviously, you do need to salt the parking space, of course. So what are you going to do? Well, essentially just drive over this test grid at a typical application speed. So whatever you're normally driving at, 15 miles an hour, perhaps, and just apply material as you normally would. And then you're just going to sweep it up and weigh it. So this gets you to your application rate directly. There's no calculations at all. You're just weighing the material that you put down. Of course, there are some variables to keep track of. You've got your gate height, you've got your auger or belt speed, you've got your pony motor RPMs if you have a pony motor. If you have a hydraulic system, like I'm sure most of you do, you don't have to worry about that. If you do have a hydraulic system, though, a couple of things to be concerned about. Number one, that you've topped up your hydraulic fluid. And number two, that the hydraulic system is actually warmed up when you're doing that. So you want to warm up the truck itself, but also get the hydraulics warmed up. So you probably have to spread a little bit, run the spinner a little bit to get that hydraulic fluid warmed up. If you forget to do that, as I sometimes do, once you get to your third or fourth run, the hydraulics will be warmed and you'll start putting down a lot more material than you were before. So you'll know you forgot to warm up the hydraulics and you have to start over. So you try to remember to do that. So this is what that looks like out in the world. This is actually in Minnesota in 2008 with their DOT. So it's very, very straightforward. There's no math. It does give you a really good idea of spread pattern. That looks like a German spreader. I think that's a Schmidt spreader. So it's very easy to understand. So in that regard, I think it's good. It's kind of a lot of work. So that is its downfall. You can definitely do this for a roadway as well. You wind up with kind of odd numbers because we want pounds per lane mile. So we've got a typical 12-foot lane. And then you wind up with 52 foot 9.5 inches. That's just because a mile of road is 5,280 feet. So in this case, you would drive over, you're looking for just that blue area, apply your salt, and then sweep it up and multiply that by 100, and that will get you directly pounds per lane mile. So generally speaking, whenever we talk about calibration, I like to set everything as low as you can if you're calibrating in this manner. Put the gate as low as you can stand it without it clogging up, and put the auger or the belt as low as is reasonable. And then you're going to change one thing. And there's a few different ways to do it. In this method, you would pick one thing to change. So you'd start as low as you can. That would get you your lowest application rate. And then either change the gate height or the auger or belt speed. Which do you change? Depends on the equipment. Right, there are some pieces of equipment that somehow the difference between 2 and 3 on the belt is triple. So maybe that's not a good thing to change. So that then you would go to the gate height, maybe raise it ½ an inch to get a little bit of a higher rate. I prefer changing the belt speed, obviously, because you don't have to get out of the truck to do that. But it really depends on the piece of equipment. And you do want to look at calibrating each piece of equipment, even if it's the exact same spreader on the exact same chassis, you bought them at the same time. They might be different. Just maintenance over the years, you replace a couple of hydraulic lines, a gear here or there, they just start getting different. So you do want to check each piece of equipment. Probably the most consistent that you'll see are the electric spreaders. I'm guessing most people on this call don't have too many of those, maybe for parking lots. Those tend to be pretty consistent. The hydraulic ones, not as much, so you do want to calibrate each piece of equipment. So there are basically two ways that most people calibrate their equipment. So the first way is kind of what we were just talking about, except you don't actually mark out a huge test grid. And just one moment, there are a couple folks waiting to come in. You don't need to mark out the test grid. This is the way that I typically do it. I'll show you the other way that's also very common. And if you do have a fancier piece of equipment that you can just dial in your application rate, those should also be calibrated annually. But they have a calibration mode usually in the computer where you go into calibration mode and it will tell you, go put a bucket out the back. I'm going to dump some salt and key in how much that weighs, and then the system's calibrated. So if you have a fancier controller, they definitely have calibration modes, but I'm talking about the general way without a fancy controller. So we park the truck, we would shut off the spinner if that's easy to do. We'll set the gate height low, maybe 1.5 inches. Set the auger or the belt on its lowest setting. And if we were doing this in person, we would put a tarp down under the back of the truck just to catch the salt. We would run the spreader for 30 seconds, so really straightforward. We really want how much comes out in 1 minute, but I do 30 seconds and just double it because it's a lot lighter. And then you do some calculations. And Mike did send out a spreadsheet that I've used for quite a while. There are a few different versions available. So basically, you would do this 3 times for a particular gate height, say if that's what you were going to change, then raise the gate height 1/2 inch, take 3 more measurements, raise it 1 more time, take 3 more measurements. And that'll give you kind of 3 application rates. You can keep going as well. Couple of details maybe. You have 2 types of people in the world. People that will sort of maniacally scrape all of the salt off that's building up on the spinner every time, and people that completely ignore the fact that salt is building up on the spinner. Doesn't particularly matter which type of person you are, just don't change your stripes in the middle of calibration. If you're going to clean it off every time, great, clean it off every time. If you're not going to, don't start. Basically, your first measurement will be a bit off as the salt builds up on the spinner. Then subsequent runs, it won't really be able to hold much more, so it will kind of take care of itself. Again, I talked about warming up the hydraulics. That's a common thing that people forget. And I mentioned this is kind of the only way to tie back what you want to do, and we'll see on the calculation sheets. This is the calculation sheet that I use. It's a little bit different than the video we'll take a brief look at. So this is for gate openings. So you see we have 1 inch, 1.5 inch, 2 inches. This is the spreadsheet that Mike sent out, so you don't have to do the math here. The spreadsheet does it for you. You would wind up with one of these for each piece of equipment that you were calibrating. So we'll fill it in with numbers. So what this is saying, I recorded a spread width of 12 feet, which is about where I want it. Column A is, oops, sorry about that. Clicked. One moment. Okay. So this is for a parking lot. So it's saying my gate openings at 1 inch. I recorded those purple, run 1 through 3. So I was getting about 70 pounds per minute out the back. We just take the average of that, and then the green are the actual application rates, and they vary by speed. So if I am at a 1 inch gate opening and going 5 miles an hour, I'm putting down 13.93 pounds per 1,000 square feet. And again, remember, we're talking parking lots, so it's pounds per 1,000 square feet. We'll look at lane miles in a minute. So if you look at this chart, 5 miles an hour, about 14. If you go up to 25 miles an hour, you're less than 3, right? And this makes sense because it's the same amount of material per minute coming out the back. The faster you go, the more pavement you're covering, so the rate goes down. So you can see we opened up to 1.5 inches in the next row down. If we look here, getting about 92, 80, mid 80s to low 90s coming out per minute. So we take the average of that. The math is not important. The numbers in the box are important. That would be your pounds per 1,000 square feet. At 1.5 inches, going 15 puts you at about 5.82. You might be looking at these numbers going, those are awfully precise. Yep, they are. You're not going to get these exactly, obviously. You're going to be slowing down and speeding up and so forth. But this is kind of a guide. You want to be looking at the pavement temperature. You want to be looking at the type of precipitation that's coming down, and then get your calibration sheet and figure out how you're going to dial in one of these rates. So say you look at your application rate chart and you want to be putting down 7 pounds per 1,000 square feet because of the pavement temperature. You would say, oh, maybe 2 inches, and if I go around 15 miles an hour, I'm good down to about 7 pounds per 1,000 square feet. And it's that connecting of the rate that you want to put down, and how do you get that out of the truck if you don't have a fancy system that you can just kind of punch things into. I was out in Nevada when I was doing the Lake Tahoe training. I also trained the Nevada DOT. That worked up in the northern part of the state. And, I was talking to them, and they were really good guys. We were talking about application rates. And they said, yeah, we use 300 pounds per 1,000 square feet. I'm sorry, 300 pounds per lane mile, excuse me. And I said, oh, okay. Do you calibrate your equipment? They go, well, sometimes. I said, oh, well, why don't we, it was a little bit of a setup. I said, why don't we do a calibration run, and you set up the truck for, you're getting your 300 pounds per lane mile, that's a good answer. So they set the gate, they set the auger. They said they would be going, about 35 miles an hour. So they set everything up, and we did a calibration. They were around 1,200 pounds per lane mile was coming out of the back of that thing. And it's not their fault, really. They had never really measured it. So once we measured it, they realized, oh, you have to really choke back the gate in order to get that 300 pounds per lane mile, which is what they were shooting for. So this is kind of the connecting the dots between what you want to do and making your vehicle actually do that. So we can do the same thing for calibrating into lane miles. And again, I'm showing the gate opening here. That could just as easily be leave the gate at whatever your standard setting is and just adjust the belt speed. So essentially same thing. I just do 3 runs to get how many pounds per minute are coming out the back. If we were doing this live, you would see me struggle with a tarp with 70 pounds of salt in it and try to weigh that. I don't use any special equipment to weigh it. I just have some big Rubbermaid totes. If you go that route, you do want to buy a couple of them. It's generally pretty cold out. They're not meant to haul around 100 pounds of salt. So they do tend to crack after you've done, 5 or 10 trucks. I use a bathroom scale. It's actually tough to find a cheap bathroom scale that's analog. The digital ones don't work very well, mainly because you're not going to be able to balance that load of salt on it very well, and it's going to read an error because it'll be all off kilter. So I just use a Rubbermaid bin and a cheap bathroom scale, honestly. So you can see the results we get here, pounds per lane mile. These are probably more familiar numbers to all the folks on the call, but same methodology. So basically, this is kind of what you see most of the time. You've got your tarp, 5-gallon bucket doesn't work, that's false advertising. But you just want to collect that material, weigh it, and you can run through it. And I'm going to bring up a video. Bear with me for 1 second here. We won't watch all of it, but I just want to highlight a couple things. It's kind of long, but let's go through a little bit of it. So you can see here they have a scale on their loader bucket, which is actually kind of cool. And you'll notice they do it a little bit differently, and this is a perfectly fine way to do it. He's just talking about weighing it right now. The way that they're going to do it is they put that little piece of paper, you see that on the auger, he'll show you in a minute. What they're going to do is weigh the amount that comes out in one full rotation. And then they're going to adjust the belt speed and count how many rotations at each speed and do the math. So this is a traditional way to do it. I didn't mention that you want to keep your engine RPMs kind of around where they will be when you're driving. That's for the hydraulic systems. So if you're curious about this way to do it, this is maybe the more traditional way. There are videos on YouTube. It's very, very straightforward. This one, you can see their calibration chart. Same basic thing. The difference is they get 22 pounds coming out per revolution, and then they count the revolutions and do the math to get down to the actual rate. So you'll see here they start with 0. So this is how many times the auger is going to spin, basically. Get pounds per spin, and then figure out how many spins for each of the settings and do the math, and that gets you your calibration rates. There are 4 or 5 videos that will show you how to do it this way. Neither way is better or worse. They're just different. The way we first talked about, you don't count the revolutions. You just directly weigh the salt. In this, you get pounds per revolution and then count the revolution. So you only weigh the salt once. So both perfectly valid. You can see what I searched, salt truck calibration. You'll get 3 or 4 videos that are all pretty good. So that's a good refresher to have there. I won't go through the whole thing or the narration, but just so you get a little bit more of a visual there. Any questions or comments on calibration? Okay. So let's go through the preseason review. The 2 biggest things that we talk about are really make sure you have your policies in order. Obviously, you want to get an attorney involved in that. Your calibration saves you material and money. So I always say I think the calibration is the most important thing as a takeaway from this. If you take nothing else, it does not take very long to calibrate your equipment. It is not at all cost prohibitive. And it really is that way to tie everything back. So you know how much material you're applying. You want to keep those calibration charts in your truck so that your drivers know how to get the appropriate amount of material out of that particular vehicle. And that's really what allows you to go out, check the pavement temperature, and then kind of radio out, this is the application rate that we need to be using. And the operators can then get that out of their truck appropriately. So calibration is really huge. It does not take long. You can do it very, very cheaply. So I'd really highly recommend if you haven't done that would be something that you take a look at. So now we're going to talk about before the storm activities. So trying to be proactive. We're going to talk a little bit about winter weather and precipitation. I'm going to kind of blow through that fairly quickly. Anti-icing, why do it? We'll talk a little bit about the science of anti-icing. We'll talk about cost savings and improved results from anti-icing. We'll talk a bit about anti-icing chemicals. We'll talk about brine making and storage. We'll talk about application methods and rates, and then some tips to get started. So let's get right into it. So we talk about winter precipitation. Like I said, I'm not going to go into great detail. I know Mike sent out copies of the slides, so these are kind of neat to look at because you have to think about them a little bit. So we'll go through them fairly quickly. I would also mention, I'm sure some of you already do, but it is worthwhile, depending on where you are, to get a custom meteorologist service so that they'll do actual forecast for your particular town. This can be helpful if your town has elevation, right? If you're a bit higher than the surrounding area, so you tend to get more snow. If you're by the ocean, certainly you get a little bit different weather. So it can be useful if your weather's a little bit atypical of the surrounding towns to have that custom forecast to really dial in your operations. So what we're concerned about a lot is the pavement temperature and what's coming out of the sky. So let's talk about what's coming out of the sky. So this is largely controlled by the air temperature at the different elevations and the shape and depth of the temperature zones. So when we're looking at snow, it's really just a deep cold layer, right? So that's what we get in snow formation. When you start looking at sleet, you have a cold layer top and bottom and then a shallow warm layer. So these are the types of things that meteorologists are looking at to try to make the prediction. Is the air temperature change as it's going up into the cloud layer. Freezing rain, very similar to sleet, but the warm layer is deeper. It's just a little bit about kind of why the precipitation forms in the way that it does. Also, another important thing to look at when you're looking at a weather forecast is look at the air temperature and the dew point. The dew point will tell you when things will start falling out of the sky. When the air and the dew point are the same temperature, you get 100% relative humidity, that's when things start falling. So what do you want to do with the dew point information? Well, lower dew point holds less moisture. Therefore, the snow will be light and fluffy. Basically, as you guys know, the temperature of the storm is what controls the type of snow that you get to a large extent. That nor'easter that we just got, my town was forecasted to have, I think it was 8 to 12 was what they said when I went to bed. It started snowing at 10 p.m. By 4 p.m. the next day, we were a little bit over 36 inches of snow. It was because it got really cold. It got colder a lot faster than they thought it was going to be. So keeping an eye on that dew point will give you some insight. Higher dew point, hold more moisture, so that's your wet, heavy snow. And of course, black ice forms when the dew point and the air temperature are equal and the relative humidity is 100%. So if the surface temperature is also below freezing, this is where you get black ice. You get that condensation on the road that freezes. Just a little bit about some of the factors of snow here. Higher temperatures, warmer, stickier, lower is drier and fluffier. You guys know that. The effect of moisture. So this is a little bit complex. If you look at the left to right axis, that's your surface temperature below freezing or above freezing, and then your air temperature going up and down below and above freezing. So when we look at moisture, that upper left quadrant, so that's surface temperature below freezing, but air is above, that's where you get the glaze. And I'm just going to work clockwise here. If your air and your surface temperature are warm above freezing, that's where you get slush. Air temperature below, surface temperature above, that's where you get your wet snow, characterized by those tire tracks. And then if everything's cold, you get powder. So I'm not going to spend too much time on these, but I think they're helpful to have. There's some additional information you can look at your own pace. These are in the handouts that Mike sent to everybody. So this is just the different impacts of having warm air or cold air and warm surface and cold surface. It impacts the density, it impacts the adhesiveness. So kind of having that data on where the air temperature is and the ground temperature gives you a lot of information on what you're going to be dealing with out there. We also have road weather information systems. These aren't commonly had by municipalities or private sector folks. This is usually with your DOTs. So you'll see these on the side of highways. This is out in the desert. But you'll see them around here. They look just the same, usually fenced in. And it's just a bunch of sensors that are actually embedded in the roadway in addition to the sensors that you see on that structure. So it looks at air temperature, it looks at relative humidity, wind speed, the precipitation, type and amount, visibility, barometric pressure. And then embedded in the pavement itself you get the surface and subsurface temperature as well as the presence of ice and water. So commonly called RWIS systems. You don't usually see them on municipal roads. You do see them in state departments of transportation have them. They don't usually share the data, but this is kind of how they inform. If we look forward several years, maybe this will be something that's used on local roads if the cost comes down. But this would be how the state DOTs get this sort of data. So again, kind of the long and the short of the weather. I'm sure you guys are all expert amateur meteorologists, but worth kind of thinking about a little bit. And if you do have elevation or ocean exposure, it might be worth looking at getting a custom meteorologist to dial in your forecast. They're not tremendously expensive, or at least they didn't used to be. Who knows? Everything's upside down these days. So again, the precipitation is key. Pavement temperature is the other key, which we're going to talk about pretty extensively. Okay, so we're still before the storm. We've calibrated our equipment in the springtime. Now we're dialing into, it's going to start snowing in the next 24, 48 hours. What do we do? One thing to think about is pre-treatment, anti-icing. So anti-icing is applying chemical to a roadway before the storm begins. And the purpose is to prevent snow and ice from bonding to the pavement. So this is the only proactive tool we have in winter maintenance. Everything else we're reacting, right? We're letting the mess occur and then we're going to clean it up. So what you're looking for here is really a bond breaker, right? You want the snow and ice to not bond to that pavement so that you can mechanically remove it, just like greasing a pan before cooking. It also has the added benefit of jump-starting the melting process. We'll talk about that a little bit more, but getting that chemical on the roadway before you actually put down your salts can be very beneficial. So anti-icing. If I were maybe trying to sell you anti-icing equipment, I might put on my brochure that it's a 75% material reduction and 90% cost savings. That's probably not totally accurate, but the numbers do come from somewhere. 75% material reduction revolves around the fact that we're going to be talking about salt brine, which is about 75% water. So you're definitely going to be using less salt. 90% cost savings, I don't know about that. Usually I've heard 10, 20%. You definitely get improved results. So what we're looking at here, this would be the advertised section. We've got that green area of pavement that we treated with anti-icing, and then the red area and the rest that we have not. This makes it look like magic. It's not magic. It will look like this for a little while. The snow will melt as it hits that area that's been pre-treated. Eventually it will build up. The benefit is really that it's not going to bond as well, so you're going to be able to mechanically remove it. And obviously YouTube has all of the answers, so if you do any searching on YouTube of anti-icing, you'll come up with some really cool videos of people actually anti-icing pavement before the storm, and then they show you the first push and the difference between the surface they treated and the surface they didn't, which is pretty amazing. I will also say it's a very nuanced thing. I think it's definitely the most complicated element of winter maintenance. It takes a bit of skill to get it right. So if you do try it, or if you have tried it and it wasn't quite as great as you were expecting, give it a little bit of time. There are definitely some tricks both on the material side of the world and the application side of the world, when to use it, when not to use it, and so forth. It's definitely fairly nuanced to get it just right. So why wouldn't you do it? How much is this actually going to save you in terms of material? Well, let's take a parallel example. You have a stick frying pan. I don't know why stick frying pans exist, but let's just go with it. You decide you're going to cook a steak, no butter, no oil. You're not going to get in front of this at all. It won't taste very good either. So then think about this pan, the effect of cleaning time. The effect of how much material, soap and water that you're going to use, right? All of them are up. The amount of force you're going to have to put into scrubbing that pan to get all of that off. This is essentially what we're doing if we're not pre-treating. We're just letting the mess occur. We're not taking any proactive measures, and then we're coming back and trying to clean it up. So certainly it's going to take more pushes. It's going to take more de-icing. It's going to take more time overall. So there's definitely a very logical side to anti-icing, and you see it done quite a bit more than you used to. I will add, anti-icing is not new. Not at all. Anti-icing was around in the 80s. If you start looking for federal highway papers, you'll find anti-icing being talked about in the 80s. And a couple of things happened. They developed it. They thought it was a good technology. People started using it. Then you had two circumstances. You got a couple of accidents, and people blamed the anti-icing. Whether or not they were at fault, who knows? I would guess not. And residents started complaining that their cars were rusting, and certainly it had to be because of the salt water that the DPW was spraying on the roads. More likely it was just because cars rusted a lot more in the 80s than they seem to these days. But basically those two things made people throw up their hands and say, well, this is too much trouble. Nobody seems to like this, so why are we bothering? Salt was also a good deal cheaper back then. So fast forward to now, the cost of salt is going up. The environmental impacts of salt are building up. So this technology is starting to re-emerge, but it is not new. There are definitely jurisdictions that have been doing this since the 80s. But you'll see it a lot more, especially as you're looking for it. So what are the effects of anti-icing? So you're going to use more liquids. You might not be using any liquids now. You should be using overall less solids. You should be using overall less total salts and abrasives. Your environmental impact should go down. The useful life of your infrastructure should go up. And I'm talking your bridges, your trucks, kind of everything, and your total operational cost should go down. Now, all of these lines are at kind of 45 degrees, so don't take their slope to mean anything. These are just meant to be kind of overall trends. When we talk about the practical impact of anti-icing, you've got a couple major benefits. This is not a 2 o'clock in the morning activity. You can definitely anti-ice during normal business hours, so you're not getting into overtime with anti-icing. And it can stay for quite a while. We'll talk about the chemicals that we use, but essentially you get out there before the storm, during normal business, pretty fast to get the roads coated down, your parking lots coated down. Then you go about your operations as you normally would. You plow, you salt, and you clear the roadways. And generally speaking, you might lose or be able to not do your last runs. You might lose a run on the other end. You'll definitely get higher quality clearing because you'll have broken that bond. So what do we talk about when we talk about the chemicals that you put down? So this is the same cast of characters, whether we're talking about a dry salt or making a salt brine. So you have sodium chloride, just your regular rock salt. You have magnesium chloride and you have calcium chloride. So sodium chloride is what everybody uses. And you can see there the working temp around 20 degrees. I usually go down to 15. 15 to 20 is when your regular old rock salt, not treated with anything else, will stop melting very effectively at around 15 or 20 degrees. If you go to magnesium chloride, works down to 5 degrees. If you go down to calcium chloride, it works down to negative 20. So these are all chlorides. The difference is calcium chloride melts to a really low temperature. And what you'll find, and there's entire courses about making brine. You can use all of these things together. So if you're clever and making a brine, you might use a base of regular rock salt and then add in some percentage of calcium chloride to lower that operating temperature and speed up the melting and the bond breaking process. So these are your chloride-based chemicals. You essentially would just make a brine with them, which is just adding water. The non-chloride, calcium magnesium acetate or CMA and potassium acetate. So same trend here you're looking at. CMA stops working at around 15 or 20, whereas potassium acetate works at a much lower temperature. They're priced accordingly. Both of these are very, very, very expensive. $1,000 a ton. So I don't expect anybody to actually use these. But I think these might be what actually the New Hampshire DOT is looking at for that one exit that I mentioned, where they're having trouble getting the chloride load down. If you need to get melt, but you cannot use chloride, these are your alternatives. Sugar also works. We'll talk about that. I've never seen anyone use granular sugar, but it does work. You'll see a lot of sugar-based products. We'll talk about those. The beet products, anything that's kind of brown and molasses looking is a sugar-based product. But anyway, these are the non-chloride-based de-icing materials. They have their own environmental problems. We won't get into that. But they're not perfect for the environment either. So don't think that you'll just spend $1,000 a ton and you'll have no problems. You'll still have problems. They'll just be different problems, unfortunately. So again, people will make very clever proprietary blends of these things. Generally, the proprietary stuff, if it's not chloride-based, is salt-based, molasses byproduct, that sort of stuff, beet juice. But in any event, you mix those together in a clever way to get something that works really well. And you can take an entire course. There's one called The Power of Brine that you'll see around. That's, I think, a 3.5, 4-hour course of all the different brine combinations you have. Good thing to ping your DOT on. They're probably using brine and they're probably making their own mixture. You can, of course, just buy liquid pre-made. There's a bunch of different proprietary sources. They all work well. They're just combinations of this stuff that's clever, though. For the purposes of this, we're just going to talk about making regular old salt brine. So just brine and water. So for that, we're going to look at the phase diagram for salt. This is kind of a similar diagram to what you'd see on the back of an antifreeze container back when people used to mix antifreeze with water. So at the top left here, we're looking at straight water. So that bottom axis, solution concentration, starts at 0, goes 5, 10, 15, 20. That's percent concentration by weight. So at 0% salt, the water freezes, as we all know, at 32 degrees. As you follow that curve down, the freeze point is getting lower and lower and lower as we add more salt. So finally, we get down to what I call the concentration sweet spot, and that occurs at 23% solution. We'll talk about what that means in a minute, but the idea is you add salt to the water until you reduce its freezing point down as low as you possibly can get it, which is around -6. If you've ever tried the trick to cool down a beverage more quickly, you put ice water and dump a ton of salt into it. It lowers the freezing temperature of the water so it can actually get colder. It does work. You need a lot more salt than people would think you would. But anyway, 23% concentration is the magic number with salt brine. And it's super important because if you stop at 10% concentration, as you can see, you're going to freeze a little bit below 20. And it gets below 20 quite a bit in the wintertime. So you don't want to be there. You want to be down below in the -6 range, which is, again, that kind of magic 23% solution. So what does that mean? That means 2.5 pounds of salt per gallon of water. So if you're visualizing this, a big coffee mug is probably about 2.5 pounds of salt. So you need to get that much dissolved into a gallon of water. There are a bunch of different ways that you can measure your concentration. The simplest way is a hydrometer. That one in the picture is upside down. That weighted end at the top goes down. It'll bob in the water, as you can see in the image on the right. And you actually read where the surface of the water meets the little indicator here. It looks like an old-timey glass thermometer with a weighted lead bulb at the end is all it is. So you just read where the water surface hits. I've highlighted here. There's a bunch of different types of them. If you get one that measures percent salt, it'll read 23%. If it's a salimeter, it'll read 85% because it's going the other way. You don't see the specific gravity ones very often, but if you get one that's reading 1 point something, that's specific gravity. So the magic answer there is 1.176. And all that is that's 17% heavier than water with nothing in it. It's just a measure of the density of the liquid. So you do want to make sure that you're at that 23%. Bunch of different ways to measure this. I like to share a story. I had a gentleman that was making brine. He actually had a brine maker, but it didn't have a salinmeter in it. And you can buy salinmeters online. They're not overly expensive. They're a couple $100, but you can actually, they look like a little gun. You put them into the brine, pull the trigger, and it actually, through electrical conduction, will measure your salt concentration. So this gentleman had made some brine. He had measured the percent concentration with a hydrometer. He'd stored his brine. He put it down on his own parking lot, and it actually froze up on him. And he was scratching his head. He was checking, checking the concentration. Everything seemed to be fine. He was getting 23. So he called the manufacturer, and the manufacturer came over and took out his salinmeter and put it in, pulled the trigger, and got 15% concentration. Because the salinmeter is measuring salt concentration directly. The hydrometer is just floating, right? I mean, it's the water is getting thicker when you're putting salt in it, so the bobber floats higher. That's all it's doing. It's like you float very high in the Dead Sea. It's very salty, the Great Salt Lake, that sort of thing. You're just putting material into the water column, so it's making it thicker. That's all the hydrometer is measuring, whereas the salinmeter is actually measuring salt. And what happened was the batch of salt that he got had quite a bit of sand in it. And he hadn't noticed. He made the brine. Nothing seemed to be amiss. But it was. He had made kind of salty mud, which is not as good. So paying attention to that 23% is really important. And we'll talk about a couple different ways to make a brine. This is admittedly not a great way to do it. There are much more efficient ways to make brine, but in theory, it works like all the rest of them do. So we have on the left-hand side, we'll put some salt in that left-hand tank. We're pushing water in through the bottom, forcing it up through that column of salt. If you look at the right-hand image, it's overflowing out of our contact container and then into the brine overflow holding tank. Then we'd have a recirculation out of that right-hand tank back into the left-hand tank. So these are all batch processes. You fill the system up with water, shut off the outside water, and then keep running that brine over the salt until you get to a 23% solution. So yeah, just run that, and once you get to 23, generally you would pump it out of that overflow tank and into a holding tank where you would store it and then start the process over again. Here's another diagram. This is out in the Midwest, so they're actually using cattle feed tanks. So if you start on the top left, that's actually a loader bucket that's dumping salt into that feed tank. They have a spray bar over the top where they're actually spraying water down from above. It's gravity draining out the bottom of that tank and then into their catch tank here. So this is backwards of the way that we just looked at. They've elevated their salt contact tank and it's gravity feeding down into the brine catch tank. They would then pump it out of the catch tank back through that spray bar until they got 23% solution, then pump it off into their holding tank so that they could store it and start the process over again. So pretty straightforward. This is looking at a system like this. You can see the elevated tank close to us, and then there's storage tank kind of off in the background. You'll see this configuration quite a bit. It became fairly popular. This is one of the original designs. You can also buy a commercial unit. Anybody that will sell you any other piece of winter maintenance equipment will probably also sell you a brine maker. You can spend as much money on a brine maker as you care to, anywhere from $5,000 or $10,000 up to several $100,000 if you want a whole enclosed building, all the water piped in, salt conveyored in, that sort of thing. You can have a setup where you just push a button and it just starts making brine for you. That's on the expensive side of the world. Most of the units, since these are the same people that manufacture your spreader, if you look at this, this is kind of an old school model. There's a dump body with a V-box spreader right in it. They welded it all together and called it a brine maker. So how these work, they're mostly poly now. And again, it's the same people that make the spreader, so they just repurpose their existing design and turn it into a brine maker. You see your storage tanks in the background. In this design, you put your salt into the spreader that gravity feeds down into the dump body. They're filling it up right now, so you see fresh water going in. That would be spraying down over the salt that's in the spreader body, gravity feeding into the dump. And then you see they've got the nozzles coming out the right-hand side of the dump body there. That's their recirculation. So once this is full, you'd connect that up and pump it back into the spreader, circulate, 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 until you get your 23%, and then pump off. This is actually kind of a cool design. If you look, like YouTube has all the answers apparently, but if you look for a brine maker on YouTube, you'll actually find a gentleman who shows you how to make this unit. He has a complete parts list of everything that he ordered. And this is really clever. I mentioned that first design, not so clever. This one's pretty clever. So you can see he just cut that poly tank to give himself a hole there. He dumps the salt into that left-hand tank. You can see there's a big gas pump kind of on the bottom left. So you fill this up with your water, and he has the hose we're looking at kind of straight on with the red handle. That's just his equalization hose. His discharge hose is on the other side of that lower container, on the opposite side of the flat spot. So he actually pumps out of there, and the sprayers spray down into this rounded bottom of that tank that you put the salt in. So if you can imagine sprayers coming in from both sides and pointing down, it actually flips the salt over and really gets a lot of agitation, which is the key to actually producing your brine, is getting that agitation so that you get that salt in contact with the water. And then he's got his overflows here are going over the top here, those kind of bluish black pipes. So this can be built for several $1,000s. This is not an overly expensive unit, something you could build yourself. A lot of people throw them on a trailer. I've seen some communities share these. It's not something you need all the time. You just kind of need to get your brine into your storage tanks, and then the brine maker could go elsewhere for somebody else to make brine. Obviously, you got to make sure that you can have the capacity to meet everybody's needs, but this is something that you see portable sometimes. And this type of unit's kind of nice because you can throw it up on a shelf for the summertime when you don't need it and just pull it back down. It doesn't weigh anything. So when we talk about actually making brine, we have to talk about storing brine. You want to use double-walled tanks or have appropriate secondary containment. We'll talk about that a little bit. We want to locate the storage tanks at least 500 feet from any Class 2 surface waterway. Class 2 surface water, basically if your boots are squishing, call it Class 2 and stay 500 feet away. Your tanks want to have good surveillance for inspection and should be tamper-proof, and obviously clearly mark the contents of the tank so you know what you're actually storing there, whether it's just salt brine or calcium brine or so forth. So when we talk about secondary containment for liquids, the general rule is you should be able to contain at a minimum 100% of the largest tank's capacity or 10% of all of the tank's volume. And this is basically usually a concrete knee wall is how you see this. So you want to have all your necessary pipes and hoses within the containment area. And they recommend top loading pipes as opposed to gravity feed, just simply that if something goes wrong on a gravity feed, you lose a valve or something, you might lose all your material, whereas if it's top loader, if the pump's not on, you're not getting any material out of it. So in terms of liquid material storage, this is not good. A few things wrong with it. It's no labeled. We don't know exactly what this is. There's no secondary containment. Might be okay if there's a double wall. They don't really look like they're double walled though, but maybe. There's also no tamper proofing, and this is particularly if you're going to be storing material out in the field or someplace where it's accessible. You want to make sure that you have a lock on that valve so that people can't just dump all this material out. It does, however, have good visibility for inspection. You can see everything going on there, so that's good. If we take a look at a bit of a more robust commercial type system, this is kind of what you look at. You can see these are top loading. You've got your knee wall there going around. So again, the idea is 10% of all of those tanks need to be contained within that volume, or 100% of the largest tank, whichever's greater. So just a little bit of math there. And as you're doing that, remember that the tanks are displacing some fluid area inside your containment. So if you're doing that calculation, make sure you're subtracting the tank area to make sure that you're not undersizing your containment area. Okay, so this will be correct in terms of storage. A bit industrial here, but so let's review this, and then we can take maybe a 10-minute break here at the top of the hour. And I want to re-go over this when we get back, so we'll hit this slide twice. So you only want to apply when your pavement temperature is between 15 and 35 degrees. If you're using calcium chloride or magnesium chloride, you want to be very careful above 35. It gets very, very slippery. You might be looking at these numbers saying, well, 15 makes sense, but I thought you said it freezes at -6, and 35, why if it's warm? So 15 is just because we don't want to be anywhere near -6. You do not want this stuff freezing, so we want to stay quite above that at 15. The 35 degrees is really because it gets a little bit slippery, and that's not at the freezing point yet. So we want to be a little bit closer to the freezing point before we start breaking out the anti-icing. Optimally, you want to do this 1 or 2 hours before the storm, but again, this is not an overtime activity. This can sit up to 24 or 48 hours. And if you're using one of the agricultural byproducts, so if it's a brown liquid that's sweet and sticky, that means it's some sort of agricultural sugar-based product, that actually sticks a lot better. So if you want to do a 48-hour advanced application, those agricultural products work better because they're sticky. So again, you can do this up to 24 hours in advance of the storm. If you're looking for an application rate, 1/2 gallon to 3/4 gallon per 1,000 square feet is a pretty good rule of thumb. If you're using a proprietary material, go ahead and ask them what they recommend for an application rate. And the last thing I'll leave you with is, unfortunately, and this is the most disappointing, anti-icing is not advised prior to freezing rain events. And that was the most disappointing thing I found out about when I was first learning about this technology, because I thought this would be wonderful for freezing rain. I will say, though, this is becoming a little bit more contentious as to whether or not the industry completely agrees with this. So I'll tell you both sides of the coin here before we break. So the thinking in saying that it's not recommended prior to freezing rain is you're putting down 23% salt brine. Freezing rain comes down, dilutes that down to effectively nothing, and washes it off the road. So it's not that it's bad during freezing rain. The thinking here is that it's not effective during freezing rain. That being said, there are some folks, and these are industry-leading folks, that are starting to think and investigate that it might actually be useful in freezing rain. And kind of where they're going down is doing a double and sometimes even triple application before a freezing rain event, so that you get so much chloride built up that dilution effect is minimized, which makes sense. And I think that goes a long way towards this winter maintenance. There's definitely some science behind all of this, but there's a lot of room for kind of dialing things in and figuring things out. So that used to be kind of hard and fast. We don't use it in freezing rain, but that might be changing just based on research that folks are doing. So something to keep an eye on in the industry. All right, I have 11 o'clock. Why don't we take 10 minutes here? So come back at 10:10, give everyone some opportunity to stretch here. I'll just put the lines on mute here and pause my screen. Again here. So again, I think this stuff, kind of at least some of it bears repeating. 15 and 35 degrees are the key pavement temperatures when you're looking at whether or not you're going to deploy the anti-icing. And again, above 35, if you're using mag chloride and calcium chloride, it can become very, very slippery. Optimally, a couple hours before the storm is the best, but up to 24 hours in advance works perfectly fine as well. And we talked a little bit about the freezing rain thing. It used to be completely not recommended, but that seems to be moving a little bit with kind of a heavy application. So application methods. Generally speaking, about a 1/4-inch stream type nozzles at a 10-inch spacing gets the job done. When I say stream nozzles, I just mean as opposed to a fan nozzle. And this is a little strange because you actually want to leave some bare pavement. If you don't do anti-icing and you've seen it around, if you've seen those wet stripes on the road before the storm, that is exactly what you want to see. This goes a little bit counter to my greasing the pan suggestion. But the idea is you want to leave some bare pavement such that if something goes wrong, either the temperature drops very quickly or your salt brine isn't exactly at 23%, you don't want to have made a perfect sheet of ice. So that's the bare pavement is another one of our insurance policies, so that if something goes awry, you have some sort of bare pavement for traction. Avoid over applying. Less is generally more. And the 1/4 type stream nozzle, 10 inches on center, if you're going under 20, is a pretty good application rate. If you're going above 20, drop hoses are advised. And all a drop hose is, if you look at that image, it would just be a hose that would stop that stream of brine from falling a foot. It would be a hose that went right down to the pavement. The problem being, if you're going above 20, you're going to lose the stream. You're going to get droplets all over the place, so you'll lose that bare pavement. So the drop hose just kind of keeps that bare pavement. If you're doing a parking lot and it's an active parking lot, you can generally stick to the travel lanes. The tires will transport it right into the parking lot for you. So here is an image from Detroit in 2005. Again, not new technology. You see a couple good things here and a couple not so good. So you see that, excuse me, you see that nice streams coming out the back. They also have the anti-icing sign, which I really like. Not many people know what you're up to if before a storm you're seemingly just spraying water all over the roads. Looks like you're up to no good. So I think anti-icing is kind of a good thing to have marked on the truck so that people know what you're up to. The thing I would discourage here is if you look on the sides of the truck, you'll notice that it's also spraying out to cover the 2 lanes adjacent the truck. So you do want to avoid that because, again, you don't have any bare pavement there. This is just kind of hosing brine left and right. You see that Jeep is kind of nudging out into the lane because he doesn't want to get sprayed. But we do like that the bar on the back. It's getting that good bare pavement. And this is what you'll see if you're driving around before a storm and people have anti-ice. You'll see this in parking lots and roadways and highways. So you can basically anti-ice with any sort of setup these days. I don't know if I would do it in a tiny little Chevy like that, but you'll find units that will fit into them. We saw a commercial unit a couple slides ago that's meant to go in the back of a pickup truck. Some people will just use tankers, full-on tankers is typically what the DOT would use. But you can buy these units to slip into anything. You can also make them. If you look at that bottom middle picture, you can see what that manifold is. You just got your 10-inch on center PVC pipe. with some nozzles. Not really much more going on than that. If we look at the bottom right, you can also use sprayer systems for your sidewalks and so forth. Again, just be careful to leave some bare pavement in case it does freeze. Yes, there's a lot of different ways to get this down on the pavement. Some people will use trailers, which trailers are not a bad idea. The caution with trailers is you want to make sure that you're done before the snow flies. I would not want to be driving a trailer like that full of liquid in the middle of a snowstorm, but as long as you can get out there ahead of time, I think that makes sense. There are also walk-behind sprayers. So if you want to get started in kind of a smaller way, you can get these little walk-behind sprayers and just do a small area of pavement. So practical tips, you can definitely calibrate your liquid application. Same type of methodology that we talked about. Generally speaking, though, if you're going less than 20 miles an hour and you've got your 10-inch on center, you're usually pretty good. Some people will put baffle balls or use baffled tanks. This can be beneficial because it keeps the liquid from sloshing around. I've not actually seen anybody use baffle balls specifically. I have seen several times people just use PVC under drain, like for a foundation, and just cut that into kind of 1 foot lengths and throw it in there. It will keep the sloshing down, which can be pretty handy. Also beware of clogging, particularly if you're using the agricultural products. You've got all that sugar in there. You want to be cognizant of having an inline filter so you have something to change. You can see here all the brown. This is an agricultural product here. Fuel filter's too fine, but just kind of a general automotive filter with a cartridge that you can kind of clean out to trap some of the sediment. Definitely helpful. Another kind of practical tip, be cautious about anti-icing around doorways, particularly if you're doing, maybe a public school or something that has these linoleum floors. You want to make sure that there are rugs to dry off, of course, and, particularly remember if you're using the mag chloride, the calcium chloride, that stuff gets pretty slippery in the warm weather. And we're talking before the storm where people will get that on the bottom of their shoe. They'll walk in, they might take a tumble. So make sure if you are anti-icing someplace like this where people would be able to track it in, that you have rugs set up and that sort of thing so you're not causing a worse situation. And like I mentioned, there's a lot of nuance to this. Things like this, if you're anti-icing in front of someplace that has this type of floor, you need to be careful. Another trick that can be pretty helpful is if you're anti-icing on a hill. Generally, you can go drive from the bottom of the hill up to the top of the hill, and then just pause for 5 or 10 seconds at the top of the hill while applying material, and then go on your way. The reason for that is gravity, right? We want to leave a little bit of a surcharge at the top of the hill so that as it starts flowing down, we don't lose the coverage of that hill. So that's kind of another tip. And it's kind of infinite tips with anti-icing on the different brines to use, when to use them, application tricks, and so forth. So definitely nuanced, definitely the most complicated thing in winter maintenance, but pretty high yield as well. So what about anti-icing with solids? This always comes up. Does it work? Yes, it can. This is one of those yeah, but scenarios. It does work. You guys know it works. You just have to be kind of careful with what you're doing. The application time is key. So you want to apply it ideally right after the precipitation starts. Why do you want to do that? Well, because all pavement is sloped for drainage. So if you put it on there a day ahead of time and traffic is going over it, pebble by pebble, that salt will start migrating off the parking lot, off the roadway, and into drainage. So you want it as close to precipitation as you can. Generally speaking, it's only effective for low speed areas, not so good for a highway speed road. It migrates off the pavement pretty quick, and you wind up with chipped windshields and so forth as they kick it up. But low-speed parking lots, regular residential type roads, totally works. The major downside is the first time you plow, you're going to remove most of your material. So that's one of the bigger benefits of using liquid, is that when you plow, you're still going to have a substantial amount of the material that stays stuck to the pavement. It's also not very effective in areas with little or no traffic. So if you have that back parking lot that nobody is going to be using at all, you spread some material on it, you can picture what you're going to get, those little melted spots where you have your salt and everything else will be unaffected. Because you really need those tires to kind of grind it up, mix with the precipitation, and make you a brine. Ideally, you'd want to use a finer grade salt for anti-icing purposes. I know you don't often have a choice, but I have seen some spreaders, or those Schmidt spreaders from Europe, they actually do grind up the salt as it's coming out of the back. So I don't know if that will migrate into more mainstream spreaders, but finer gradation would be preferable. So a lot of people started getting back into anti-icing in 2014, 2015. I'm sure you guys remember it well. Nobody could get any salt, right? There was a huge salt shortage all across the country, really. And a lot of it was because we got a bunch of storms really quickly, and the salt wasn't here. So a lot of people basically had no option, right? You can't get salt. You got to make the salt you have go further. So people started using brine. They started using brine on their salt itself, as we'll talk about, and they started doing anti-icing as a measure to use less salt. And it was definitely effective, for sure. So let's touch on the other things. What about those weird chemicals? I seem to see either on social media or news, or it seems like every season I see something about some municipality or Midwest municipality making roads safer with beet juice. So as I mentioned, basically anything, sugar works the same as salt. There's not much difference. You could put sugar down on the roads and it would work just fine. So we tend to use sugar byproducts that would otherwise be waste products. Probably the most common is sugar beet juice. So beets provide 20% of the world's sugar, fun fact. You can use 80% salt brine, 20% beet juice, so you mix it. The environmental plus is it's not a chloride. It also lowers the effective operating temperature below 15. So it's a good alternative. Basically anything that's waste that's sugar-based you can use, though. So in Wisconsin, you'll see that they use cheese brine. You can use brewery byproducts. These are kind of molasses-based products that you can mix with magnesium chloride. In Russia, they've tried vodka distillate, the sugary byproduct of making vodka. So any of these kind of waste products that don't have chlorides are good. You'll see a lot of these in the proprietary mixtures, the brownish mixtures. And we just generally refer to them as the agricultural byproduct range of chemicals, essentially, just all of these sugary byproducts. So you want to get started, and maybe you don't want to take my word for it and go out and spend a bunch of money on equipment, but you do kind of want to test it out this year. You can just make a small batch of brine. 11 pounds of salt in a 5-gallon bucket will do. I'll give you a heads up, it's not going to mix in very easily. It's going to need quite a bit of agitation. You can check your concentration using a hydrometer, and then just recreate this experiment from the first slide on anti-icing. You can spray down an area with just using a masonry sprayer or something. I wouldn't do the front walkway like this. I'd probably do something out of the way for your first test. But recreate this on your own. Take a picture of where you treated, where you didn't treat. Take a video of your first push and prove to yourself that this would be a beneficial technology. This can also be helpful if you're trying to justify to the selectmen that this is something that the town needs to implement, and proves to yourself that this is something that's worthwhile and something that's actually effective. So once I get through this, if anybody would like to share their successes or not successes with anti-icing, that'd be great. So just kind of a high-level review here. So anti-icing is proactive and can significantly reduce time and cost. Remember thinking about that pan. Definitely less effort, less material, less chemical if you get out and pre-treat that pan so it's not bonded. So remember, the purpose is to prevent the snow and ice from bonding to the pavement. You'll see people trying to melt with brine. You can. That's not the most efficient way to use it. You want to prevent that bond. So 23% solution is super important, particularly if you're making your own brine. You can just buy brine these days. People will just come deliver it right to you. But that 23% solution is key. Remember, if you're using mag chloride or calcium chloride, they both work very well. Calcium chloride melts like crazy. But they're not recommended in brine form above 35 degrees because they get slippery. And then stream type nozzles to leave some bare pavement so you can get traction in the event of a slippery condition, whether it's the brine wasn't exactly at 23 or the temperature dropped suddenly. So that is our before the storm. I know it's a lot. Anti-icing is one of our more complicated topics. There's kind of a lot there. But definitely something that you can tackle and deploy. So anybody use anti-icing in their community successfully? I'll just look for folks to come off mute if you have or if you care to share.
I actually had a question.
Sure.
Was wondering if you've ever had any experience with products out there using the tree malignant.
No, I have not actually.
So there's a product called Safer Roads, and it's supposed to be able to be used as a anti-icing in the winter and then a binder for your dirt roads in the summer. So it was kind of a dual purpose product, and we were looking into getting into it this year. Haven't quite made that decision yet, but I was just looking for some feedback if anybody out there's used it.
Yeah, I have not heard of that. Has anybody else heard or tried that? I guess not. Any other comments about anti-icing? Okay. I guess now you made me think of something I heard about. It was actually from your region. Question came up last year or the year before, I think, when I was doing this class in person. And the question was, does fracking liquid work for anti-icing? And that caught me off guard. Not expecting that. So number one, fracking liquid is proprietary. So you don't know what's in it. And if you're not familiar with fracking, they pump in usually a liquid at high pressure, crack the rock apart, pump in what they call proppant, which is a liquid that just has stuff in it, sand, to hold the cracks open. And they pump all of that out and go after whatever they're looking for, whether it's gas or oil or what have you. So they wind up with this waste liquid. And if you take away the proprietary chemicals that they add, which I have no idea what they are, it is fundamentally salt water. That's what they start with. So would it work for anti-icing? It probably would, since it's salt-based, but again, really tough to say since it's proprietary. Would it be a good idea? Probably not, because you don't know what's in there, so you don't want to be spreading that around. So you do get some of these things that are like, I suppose it would work, but also probably wouldn't want to be spreading that on the roadways because you don't know what sort of petroleum products it picked up in the process. So that was a new one that came up last year as well. Okay, well, let's go a little bit further then. So now we're at our during the storm activities. So you've got your plowing. We'll spend a little bit of time on plows. Not much. You guys know a lot about plows, although I have to say there are some new cool plows that are coming out of Canada. They're kind of neat. We'll take a look at de-icing alternatives. We'll take a look at how salt actually works. And you guys already know how salt works. You probably just haven't thought about it. We'll talk about pre-wetting and pre-treating, how they impact application rates, what we refer to as bounce and scatter, and savings that you can get from pre-wetting or pre-treating your salt with a liquid. We'll also talk about salt application rates, timing, and effective temperatures. We'll do a little bit of examples on application rates, how to determine your correct application rates, and then a little bit about material storage. And I'm just looking at the clock here. We're probably not going to go all the way to 1, so you guys will get a little bit of time for lunch here before the afternoon, just as I'm looking at the amount of content we have left. All right, so going into plowing. Plowing is the most cost-effective way to remove snow with the least environmental impact. We always say plow early, plow often, plow, plow, plow. You avoid compaction. Mechanically removing the snow and ice with a plow is the most efficient thing that you can do. So you want to get as much work done with the plow as you can. And this breaks down, but you always want to plow before you apply the salt. And obviously, at some point, that stops, and now you're salting and plowing. But to the extent that you can, do the work with your plow before you put on the salt. Reason being, your plow is going to remove the salt. So get as much of the material away, then put your chemical down. You never want to burn the snow or ice off, and I know this, everybody knows this. All you're doing with your de-icer is you're trying to loosen that bond so that you can mechanically plow it away. You guys know all of this stuff, but there's several different types of plow blades. You've got steel blades, carbide blades, rubber blades. Joma blades, I always mention because it seems like only DOTs have heard of them. They're kind of a rubber steel composite, rubber on the outside with a steel core. They're fairly expensive, but people that use them seem to like them. You've also got your rubber blades that you would see on your pushers. We're all familiar with this. Underbody plows, you don't see these very often. I've seen a few municipalities use them and they love them. You can imagine why. You get the entire downforce of the truck. Usually you can lift up the truck. So you get a lot of downward pressure and you can really break up the ice in the hard pack very, very well. You'll also take any unwanted pavement with you. So you really only would want to use this on high quality pavement. You'll see this sometimes. I don't see it very often. If you go to the snow and ice conferences, you'll see some of these multi-blade plows kicking around. This is like if Gillette made a plow, it'd be the Mach 3. It's kind of clever. It's got a carbide blade for the first blade, then what they're calling a scarifying blade, which is kind of like a tined blade, and then a rubber squeegee blade at the back. So you got your carbide to do most of the work. You've got your scarifying to break up what's left, and then your rubber blade to remove all of it. This is the typical configuration. I've seen these on blocks. It seems to make a lot of sense. I guess the downside is maybe you're using 3 blades at once, so it costs 3 times as much to use. But something to keep an eye out for. They are kind of dialing into plow technology. There are some cool blades coming down out of Canada. I think they're carbide blades, but the whole blade is sectional on springs. So if you hit a manhole cover, only, the 3 feet or 2 feet that are smashing into the cover will flip, and the rest of the blade will stay in contact with the road. So kind of cool plow blade technology coming out. But we won't spend too much time on that. Let's talk about our de-icers. So this is the same cast of characters that we saw for making brine. These are the chemicals that we use for de-icing too. So again, your sodium chloride, your regular old salt, your magnesium chloride, and your calcium chloride. Again, the difference being the price and the working temperatures. A little side note here, if you do have a chloride problem, Calcium chloride has double the chloride that sodium chloride does, just chemically. So if you have an impairment already, you probably want to stay away from calcium chloride because it has double the chloride as regular salt. It does work very well at low temperatures, though. Once again, these are your non-chloride alternatives, your acetates. They're very, very expensive. The only place I've really seen these used in a commercial capacity would be on concrete parking decks. So sometimes you'll see, you have a raised concrete parking deck on a mall or a supermarket or something. They frequently get corrosion problems, and at that point, I've seen people switch over to these type of chemicals just to left turn out of the corrosion problem because it's cheaper to buy these chemicals than it is to replace the entire parking deck. So you see that occasionally. And as I mentioned, that situation in New Hampshire where they're just not able to get into compliance, so they're looking at using alternative chemicals. So how salt works. So essentially, salt loves water. And it literally pulls the water out of the ice formation. Remember how we talked about how you needed that salt brine to start the melting, and how when you're making salt brine, you're actually lowering the freezing temperature of the salt. That all comes into play here. But kind of the heart of it is salt is very hydrophilic. It really, really loves water. And the practical example of this, if you go out into your yard now and just pick up a nice handful of salt, just kind of let it sit in your hand for a minute and drop it, your hand's going to be really dry, right? The salt will take that water right out of your hand. It really wants to bond with it. Does the same thing with ice. There's temperature issues with the ice that kind of layer on top of it, but it's that same sort of thing. It wants to bond with that water, whether it's in ice, whether it's in your skin. It's going to look to get that water out and bond it. So a couple of things here. You're melting the ice, so you're making a brine. Once you've made that brine, the melting process actually accelerates. And there's a few things going on, but it's primarily a surface area game. If you think of a dry crystal of salt sitting on your desk, it's not going to touch very much, right? Whatever jagged edges are going to be touching your desk. If you dip it in salt brine and put it on your desk, it's going to be a bunch of it in contact. You got all the water pulling things up, so it really increases the surface area. So just adding that brine really accelerates the melting process. The other important thing is that the effectiveness of salt actually changes with temperature. And I guess now's a good time to talk about it. We got to do it sometime. We're going to start talking about temperature now, and what we're looking for is pavement temperature. Air temperature's okay, but we're trying to get our melting done on the actual pavement. So we want to have a temperature gun that shoots the temperature of the pavement, not the air temperature outside your shop or the air temperature at the TV studio downtown. We want to know what's actually going on the pavement itself. And pavement temperature and air temperature can be very close to the same. They can be very far apart. A lot of it depends on the solar exposure and how quickly the temperature has been changing, right? The air can cool down and heat up a lot more quickly than the ground can. So depending on what's happening, the ground might be lagging behind and it might be warmer or it might be colder. And again, a lot of dependency on solar exposure there as well. If you don't have any sun, that pavement can get pretty cold. So taking a look at the melting capacity of salt, and this is the basis for all of the application rates that we're going to look at, and why way back a couple hours ago when I said, well, people will say 300 pounds per lane mile, which is a good answer. That is the right answer for a particular temperature. But as we're looking at here, a pavement temperature of 30 degrees will melt 46 pounds of ice. Or 1 pound of salt, excuse me, will melt 46 pounds of ice in about 5 minutes. And I know you're probably looking at this going, sounds a little crazy. This is chemically what it can do. Getting the salt in contact with that much ice would be maybe a little problematic, but the relationship holds. So pavement temperature of 25 degrees, that same 1 pound of salt only melts 14 pounds of ice, and it takes 10 minutes. Go down to 15 degrees, same 1 pound of salt, only melting 6 pounds of ice, and it takes an hour. So this is the basis why I said below 15 or 20 degrees, dry salt stops becoming very effective. This is when you think about switching over to your sand salt mixture, because you're basically throwing up your hands and giving up on the melt, just putting down some sand for traction and waiting for the temperature to warm up. Now, again, this is dry salt. There are chemicals you can put onto your salt that we'll talk about that will lower the operating temperature, like calcium chloride. People will spray their salt with calcium chloride, or the proprietary mixtures. We'll talk about those. But generally, dry salt below 15 degrees, it takes too long to do any melting, so you're actually just going to wind up scraping it off before it's had a chance to do anything at all. So that's the lower end of it and why we stop at a certain temperature. But this is also why we have different application rates. If you're putting down 1 pound of salt at 30 degrees versus 1 pound of salt at 20 degrees, you're going to get a very different result. And the general trend is as your pavement temperatures go up, your rates go down. As your pavement temperatures go down, your rates go up. On those colder storms, you will need to use more material. If it's a storm right at 30 degrees, you can probably get away with a very, very light salting and get exactly the same result. So once again, looking for pavement temperature, it's a million different ways to get pavement temperature. You can buy units that mount onto your truck here, as we see in the top picture. They have a display in the cab. This is kind of an old-fashioned one. They've been around for a while. You can get the point-and-shoot models like we see here, the handheld. They sell them at Home Depot and Lowe's. They're in the electrical cage with the multimeters and that sort of stuff. They cost about $100. They work pretty well. I will also point out that is the correct place to mount your pavement sensor, your pavement temperature sensor on a truck. If you put it behind the front wheel, you get a lot of hot air from the engine, which can skew your results sometimes. So that's actually the right spot to put it. So once again, influence of pavement temperature. Temperature goes down, rate goes up. Temperature goes up, rate goes down. So this is the whole basis for why 300 is not the correct answer all the time. It is a correct answer for a particular temperature, but you can go a bit less than 300 pounds per lane mile if it's warmer, and you need to go higher if it's colder. So it goes both ways. So let's take a look at the effect of pre-wetting salt. I heard a few people mention as they were joining the call that they use pre-wet salt or they're trying pre-wet salt for the first time this year. So this is a simple experiment here, and you'll see more closely on the left-hand side and the right-hand side. These are two crystals of salt put down on a block of ice. One of them, the right-hand one, was dipped in some salt brine ahead of time. Otherwise, totally the same. As we move forward in time, we can see the pre-wet salt burrowing way down further than the salt that wasn't pre-wet. So this is that jump starting of the melting process. Getting that brine formed is what really activates the salt and lets you get the effective melt. This also goes back to why the porous pavement is kind of a handicap because it drains that brine away. So you're never able to build that up and really start the efficient melting. So other reasons why you might want to pre-wet your salts with a brine. This is a famous study done out of the Michigan Highway Department. A bunch of different DOTs have done this. But this is what's known as reducing bounce and scatter. So what they did was they drove down and they were doing a centerline application, and they did it with dry salt and they did it with salt that was pre-wet with a brine. So if we look at the blue bars first, they did their application and then they swept it up and they measured it. They found that 46% of their dry salt, those blue bars, were in the center third of the road, 12% on each outer third, and 30% was gone. It went off the road completely into the ditch. So same piece of equipment, they loaded it up with salt that was pre-wet, did their application, swept it up again. They found 78% was in the middle third where they put it, 9% on either side, and only 4% was unaccounted for. So this is what I refer to as the spitball effect. If you think back, I don't know how far, maybe very far, maybe not. Dry spitballs don't work. They need to be wet. If you shoot a dry spitball, it doesn't stick to anything. Wet spitball, it'll stick to the wall. Obviously, paper is a bit lighter than salt, but it's the same sort of thing. You need that surface tension of the water to kind of hold the salt onto the roadway so it doesn't bounce all over the place. So this is part of the reason, the two key reasons why using salt that is pre-treated with something, whether it's a brine or proprietary chemical, is effective. Number one, we looked at it jump starts the melting process. Number two, you can actually use less material because it's staying on the roadway where you put it. And this is part of the key. I've talked to a handful of people that have tried treated salt for the first time, and they say, well, I didn't save any material. I think it worked better. The key is you do have to dial down your application rates. There are different application rates for salt that is treated with a chemical. You can actually get away with using less because of this. And because it's more effective. This is another one of the gotchas. Some of you might be thinking, I maintain a city. I don't have a ditch. I have a curb. Fair point. That's just one of those variables that plays in. In this scenario, you'd be looking at about 30% that would probably wind up being, up against the curb, not in the roadway where you want it. But definitely something to consider. If you have a scenario where it can completely bounce off the road and go into the ditch, or is it going to go onto the sidewalk maybe, the gutter, good things to think about for sure. So how do you use this brine? And again, this is something that you can buy, something you can do yourself. So we'll go through a few different ways. And it's kind of a pet peeve. The names are really annoying. One of the ways that we look at getting salt brine or liquid onto salt is called pre-treating. So this is actually wetting the salt with the liquid before you put it into the truck or before you apply it, really. You can do it in the truck too. When you do this, you use 6 to 10 gallons per ton if you're using salt brine, 23% solution. Sometimes people will apply a dye so that you can kind of keep track. They've got this fancy blue salt here so you can see what's treated and what's not treated. The reason we use 6 to 10 tons per gallon is just to keep it from leaching out. That's about as much as a ton of salt can hold. So how do you do this? A bunch of different ways. Loader bucket's pretty common. I wouldn't necessarily do it in the back of my truck just because you're spraying salt water down. You can do it yourself. Simply spread out the salt. Take your industrial sprayer that you all have in your salt palace. This is a crazy salt shed. Again, 6 to 10 gallons per ton. Mix it around with the loader and then store it for use later. There are companies that will come and do this for you. They'll come and just spray your pile for you. You can obviously buy your salt already treated, as I know a lot of folks do. Something you used to hear more about, I haven't actually heard it very much in the past couple of years, is your pile freezing up. I know a lot of people won't treat their whole pile like this. They'll kind of do it in batches throughout the season. You do hear horror stories every here and then that people sprayed their pile down and it froze up into a block and they had to use a loader and a bulldozer to break it up and it was just completely miserable. I've heard that story more than once, more than a dozen times actually, so it's definitely a real story. Hard to say what was happening, not being there, but I think a fairly good guess would be that the moisture content of the salt that they were working with was probably fairly high. So when they applied the brine material, that concentration went down way below 23%. so that it froze up at warmer temperatures. That would be my guess. So I think that it's something worth considering because it is a nightmare when it happens. So to some extent, batching does make a bit of sense. And again, the only reason that we have these guidelines on how much to put on the pile is it's about how much it can hold. If you go more than 10 gallons per ton, it's just going to start leaching out, which isn't helpful. So make sure that you're not over applying. It doesn't really help a tremendous amount. Pre-wetting. So this is the other thing you can do with a liquid. I find it annoying that the names are so close, pre-wetting and pre-treating. But essentially what you're looking at here is applying the salt brine as it's coming off the spinner. So you get these saddle tanks on your truck. Generally, they fit into the V of the spreader like that, sometimes over the cab. And basically, they spray salt brine onto the salt right as it's coming out of the back. You can get 8 to 14 gallons per ton in this manner. Nothing's changed about the salt. What's changed is where you're putting it. You're putting it on the road. It still can't hold much more than 10 per ton, but you're putting it on the road. So if it leaches out onto the road, you got a little extra brine on the road, that's not a problem. So you can get a little bit more, and this is a little bit more effective, but you have the capital cost of buying the tanks, buying the sprayer, etc. I will say, though, they make these for literally every truck, whether you've got this like 1976 model over here, it looks like, with a front discharge spreader. You can get that fitted up. You get it fitted up to the back of a small pickup truck. So basically anything can be outfit with pre-wetting equipment. They're not tremendously expensive, but certainly more expensive than just buying your salt treated. So with that being said, that's probably a pretty good place to take our final pause here. I'm just looking at the remaining material. We won't make it all the way to 1 o'clock. We'll probably make it to a little past 12:30, but why don't we come back at 5 past the hour, give everybody a couple minutes here to stretch, and then we'll talk about application rates. Okay, let's roll then. So basically, to wrap this up, we've got application rates for parking lots and roadways, and then just a little bit of housekeeping topics, record keeping, salt storage, that sort of stuff. So these are actually the New Hampshire application rates. We developed these about 10 years ago now, I think. If we look at how to use this, the first column is your pavement temperature and the trend, whether it's trending up or down. The next column is your weather condition, which basically differentiates between snow and freezing rain. And then you've got your maintenance actions, and then your application rates for salt pre-treated with a salt brine, salt pre-treated with other blends, and then dry salt. And you'll notice as you go down, the dry salt column is more than the rest. And then winter sand, you see not recommended here for most of the temperatures. There are a bunch of different versions of these application rate sheets. This is for parking lots, so these numbers look a little bit weird, I'm sure. Numbers like 4, 5, 6, 7, 8. We developed this with a team at the University of New Hampshire and some private contractors. This was later verified by a study done by CIMA at the University of Waterloo. They came up with basically the same numbers that we did a few years ago. So if we go to the next page, and this sheet is in the PDF that Mike shared with everybody. But this is basically just your guideline on parking lot application rates starting on the low side of around 4, and then as it gets colder, going up to around 10. And then you see as we get down 20 to 25, it starts getting cold. You start getting winter sand starting to be recommended. So there are a few different versions of parking lot application sheets. Application rates, basically in the 4 pounds per 1,000 square feet, up to 10 or 12 is kind of the range, the higher numbers being for use when it's colder. So you have a copy of this in your handouts. But moving on to the road application rates, these are maybe the ones that are a little bit more familiar to folks. So these are your pounds per lane mile. And when we say pounds per lane mile, probably makes the most sense to think about starting with a lane road. This, say 150 for dry salt above 30 degrees, and the upward arrow meaning it's getting warmer. That 150 would be you are driving down one side of the road, putting down 150 pounds over 1 mile in one lane, and then turning around and coming back the other way in the other lane and putting down another 150 pounds. So if you're doing a centerline application that's meant to treat both sides of the road, you have to multiply that by 2. And of course, if you're doing a multi-lane road, this is what you need for one road. So you need to put this much in each lane. So once again, we see the similar temperature trends here, with the dry salt being more material than either of the blended salts or the pre-treated salts. And again, that's part of the key of actually being able to save material. It's dialing back those application rates to make sure that you take account for the fact that you're using a material that works much better. Once again, even on the roadway, you see that the not recommended on winter sand goes down till we start getting really cold and start getting into freezing rain. It starts becoming recommended. So again, you'll find these roadway rates all over the place. Federal Highway Clear Roads has a version. This is the New Hampshire version. Most DOTs have their official application rates, but they're pretty much all in line with this. The Salt Institute has a Snow Fighter's Handbook. They have application rates in there as well. That's also a pretty good resource if you're looking for planning tools, how to estimate how much salt to buy based on the projected number of storms. They've got some good stuff in there and some discussion of insurance, which is also good topics that we're kind of skipping. So if I go to the next page here, it's just the colder temperatures. So it tells you as you go down. And again, winter sand starting to pop up as you get colder. And then you notice this break point down here when we get below 15. Now your salts, dry salt or salt treated with a regular salt brine becomes not recommended. And that's when you get completely into your winter sand or your salt that's been pre-treated with some other blends that let it operate at a colder temperature. So this is the final tool in effective and efficient winter maintenance, is varying your application rate with the pavement temperature. Remember those melting capacities. If it's 30 degrees out, you do not need as much material to get the exact same job done. Conversely, if it's colder, you need more material. So that you see that 300 pounds that I've been kind of throwing around is in a few places on this application rate chart. And if you have to pick one rate, that's not a bad rate to choose. That's a good one. But you can really vary it. If you go down here, we go back up to our warmer temperatures. If you're up above 30, you can get away with half that salt, and you should. So it's, 300 will do the job. But if it's warmer out, you can really back off and use a lot less material. This ties back to your calibration. And let's just go ahead and kind of do an example here as we take this full circle. So let's just say it's 5 p.m. You take a pavement temperature reading, you get 23 degrees, snowing, and it's getting colder. What are you looking for? We'll do parking lot rates for salt pre-treated with salt brine and dry salt. And adding a little math, how much would you use for a 5,000 square foot parking lot? So again, 23 and getting colder puts us in the 20 to 25 downward arrow for getting colder. We said it was snowing out. It tells us what to do, plow and apply chemical. And then we have our 2 application rates. And again, pounds per 1,000 square feet, because we're talking parking lots. Notice the dry salt is higher because it doesn't work as well. It doesn't jumpstart the melting, and a lot of it's going to bounce off because it's not pre-wet. Calculate the total amount to be used. So we said 5,000 square feet, so just multiply by 5, roughly 50 pounds of dry salt, roughly 30 pounds of pre-wet salt. This is also a good back of the envelope type calculation when you're looking at your plow routes. If you're saying put down 150 pounds per lane mile, how many lane miles is the particular route? Do you expect it to be the full load, half a load? Should they have to come back and refill once or twice? Just kind of a good guideline of what you're expecting to happen from a high level. Another example, it's 8 degrees, getting warmer, 9 a.m., has nothing to do with it. What application rate should we use for dry salt? If you're thinking back, 8 degrees is very cold. So that puts us in 0 to 15. Up or downward arrow means it doesn't matter if it's getting warmer or colder. And it's going to give us that answer of not recommended. So that's below 15 degrees. The dry salt stops working. So you either have to use an alternative chemical or you're switching over to your winter sand and basically giving up on your melts and transitioning over to just getting your abrasion, getting some traction there until you can get back to melting. So quick roadway example, 27 degrees, snowing and warming up. We're looking for pre-wet and dry salt and how much material for a 25-mile plow route, pretty long route. So that puts us in 25 to 30 and getting warmer, snowing. We're plowing and then applying chemical in that order. And there are 2 application rates for the different materials. So looking at the 225 per lane mile times 25 miles times 2 lanes, 11,000 pounds of salt you would need for that big route. So just kind of calibrating what's going on there. One more example here. Pavement temperatures 32, snowing and warming up. What about dry salt? So that puts us in our top column, snowing. Plow, treat intersections only. And we're looking at about 150. So we're approaching above freezing here. So we're looking at a really light application rate and it's recommending to treat the intersections. So again, kind of the bottom line with the application rates, the idea is either you have temperature sensors in your truck or somebody's going out and just taking a couple of pavement temperature readings. Figure out what your application rates are going to be. Communicate that. Make sure folks are using their calibration chart, so they're setting the belt and the gate to the appropriate height for their truck, so they're reasonably sure that they're going to get that out. The bottom line is, you're not going to be able to calibrate to these precise rates. This is not surgical equipment. The idea is to be close to where you want to be. If you have the closed loop systems, they're pretty dialed in, but if you're just using regular equipment, you want to get close. You want to be putting down, 150, 175, not 300 or 400, when you think that you're doing a low rate. You can also adapt kind of your own rates. I think that the Salt Institute rates, they only use 3, I think, last time I saw it. A low, medium, and a high. They have temperature ranges. They agree with these rates, the same thing. So you don't need to use the rates that I'm showing you. There's a few different versions. They all pretty much agree with each other. As long as you're using more material when it's colder and less material when it's warmer, you're on the right track. A little bit about salt storage here. De-icing material should be stored on an impervious surface, meaning asphalt or concrete. Ideally, you want to slope the flooring to prevent runoff. You definitely want to have your materials covered. I'm sure you guys all have salt sheds. But back when we got started, there was quite a few salt piles that weren't covered, at least. So you want to make sure that it's protected. Load equipment as close to the salt pile as possible. Obvious, you don't want the loader bouncing 1,000 feet across the yard, spilling salt everywhere. If you do spill, sweep it up and return it to the stockpile. So that's a little bit of a mess. You want to make sure you clean that up. So a little bit of a during the storm activities review. Plowing is the #1 maintenance activity. You want to mechanically remove the snow and ice. Remember, your salt doesn't really begin melting effectively until a brine is formed. That ties back to the porous pavement and why it handicaps it a little bit. Your pre-wet salt is more efficient and effective than dry salt. Remember the bounce and scatter, spitball effect. Salt, the de-icing material, is used to loosen the ice pavement bond, not burn it off. You want to loosen it up so that you can mechanically remove it. Remember that the application rates vary with your pavement temperature. Air temperature is a substitute if you don't have pavement temperature, but not as good. You want to know how to use an application rate chart, whether it's this one or a different one, and cover your de-icing materials. So I just want to do a quick high-level review of what we've talked about. And then we'll have some time for questions if you guys have any. And looks like you've got a little bit of time to actually have some lunch during the noon hour here. So taking it back to 9 a.m. Salt has hidden infrastructure costs. Remember, it's rusting everything it touches, whether it's the rebar inside the concrete, your equipment, anything steel. It has negative impacts on life. Remember, we looked at the grass, the plant impacts, it's dehydration. They're meant to be saltier inside than outside. They're not meant to live in salt water. So when we put salt into the environment, it destroys that balance. Same thing happens with fish and aquatic life. And also humans, if you have high blood pressure, it's actually the sodium, not the chloride, that's the problem in people, but they come as a package. So you want to be careful of contaminating drinking water wells with salt. Chloride exists all over the snow belt, actually. And it's really tough to get out of a chloride contamination situation once you get into one. So definitely being proactive is good. I will say, I guess, from more of an administrative point of view, if you don't currently have a chloride impaired watershed that you know of, and you are taking steps to reduce your salt usage during winter maintenance, I would be sure to document those steps if you're buying new equipment, things like taking this course, that sort of thing. I would keep all of that together in case you do ever wind up with an impaired watershed. Definitely helpful to have the documentation saying that you were being proactive in your winter maintenance and making an effort to be environmentally friendly. So always good to keep some records of your activities there. So again, coming to the pre-season, calibration is the most important thing there. Snow and ice policies are helpful, but again, calibration's cheap, practically free. And it might wind up saving you a lot of material. If you remember that that shot I showed you this morning of, is this too much material? It's too much material, right? We can agree on that. Calibration fixed that problem for sure. And they don't, that's not an issue anymore. So before the storm, remember that anti-icing is proactive, can save significant time and costs, prevent snow and ice from bonding to the pavement. Brine is most effective at 23% solution. Always check the concentration before you apply. Remember, mag chloride is slippery above 35 degrees. Sodium chloride, you want to use it between 15 and 35 degrees. Generally, remember the cold end is insurance against its freezing. And you want to use stream type nozzles to leave some dry pavement to provide some traction in the event of a slippery condition. We'll do one or two more application rate examples, and then we can open it up for questions. So 16 degrees, snowing and getting colder. We're looking for salt brine and dry salt. So let's go in. That puts us in 15 to 20 and downward arrow, so it's getting colder. Snowing and freezing rain. We're going to plow and apply chemical. And it gives us our two application rates. Of course, the pre-treated is less than the other. So during the storm activities is our last slide before we wrap up. Plowing is the #1 maintenance activity. Mechanically removing the snow and ice is preferred. Salt doesn't begin melting effectively until a brine is formed. Pre-wet salt is more efficient and effective than dry salt. Salt is used to loosen the snow and ice bond. You're not burning it off. You're just loosening it up so you can mechanically scrape it away. Know how to use on application rate chart. Doesn't much matter which one it is. Pick one that works for you. And then, of course, just housekeeping stuff. Cover your de-icing material. Store it on an impervious surface and control the drainage. So, folks, that is all I have prepared for you this morning. I'm happy